Good evening, everyone. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
So let's wait a few more minutes, then we'll start the session. Okay, now let us start the session. Am I audible? Okay, now that yesterday we have covered up to week 8. Now today we'll cover week 9, 10, 11, 12, plus we'll cover this geometric distribution. Okay,
Sure.
distribution.
Sir, a quick question on geometric distribution. The video that we saw that you sent yesterday, is that the only one that we need to look at? So, I mean, it covers geometric distribution, but it doesn't get into the expected value and variance of geometric distribution.
Whatever we will discuss towards the end of the session, and you will be getting a mail tomorrow also, most probably by tomorrow. So whatever is in the mail, that is all you have to cover. Okay, we'll be taking questions from geometric distribution as much as is required for the end term. Okay,
Okay.
so now let's start from random variable. So can anyone tell me what they've understood about random variable, what a random variable is?
It's
What
a
is
function. It's a function based on the sample space.
Exactly. So
Real valued functions.
exactly. So it is the name of variable, but it's just like a function, right? And we denote it by this capital letters X or Y, whatever we want. And the domain that whenever we have studied functions, we know the functions have domain, right? And in this case, our domain will be sample space, the elements of the sample space, basically. And what our range is going to be. What is our range? That is very important in this case. That we have seen, it is always a real number, right? So basically what random variable is, it associates a number with the sample space, with the elements of sample space, right? So that is basically what a random variable is. Now, suppose, let's move forward. Sometimes we are not interested in knowing the actual outcome. Now, basically, why do we need to study these random variables? Sometimes we are not interested solely in knowing what the actual outcome is, but we are interested in know what, suppose when we throw our die, we are interested in knowing what the sum is. So we are not interested in knowing the actual outcome. Was it 4-3 or was it 3-4? In both cases, the sum was 7, but we're not concerned with that. So we are concerned with this, like what the sum is, not the actual outcome, which outcome gave us the sum, just concerned with the sum. So these, like whenever we are concerned with such entities, such quantities, wherever we are not concerned with the actual outcome, but something related to those outcomes, we study these random variables. Okay, the value of the random variable, as we just discussed, random variable, its domain is the sample space, and its range is a real number. So what it does is it basically associates a real number with the elements of the sample space. Okay, so now the value of random variable, how it is determined, it's determined by the outcome of the experiment. And now how this random variable is defined, how to take, like how to associate, what to associate with the random variable, that is always given in the question. That is how the question will be defined. Okay, now let's start with a basic example. Suppose we roll a die twice, right? So this is our sample space. of these, how many outcomes will result in sum of 7? Basically this diagonal, right? This diagonal, 3 4 4 3 6 2 6 1. So this diagonal corresponds to all those elements that give us the sum as 7. So in this case, we can, yeah, we'll be just taking questions as well. We'll mostly take questions. Now these are the outcomes. 1 1. Let x denote the sum of two rows, right? That is, suppose x is a random variable. Now we have denoted a random variable. We can see it's associating, this is an element of the sample space, right? 1 1. It's associating a number with it. Okay. So what in this case this number is? This number is the sum of the two rows. So we are taking an element from the sample space and we are associating a number with it. In this case, it is the sum when we are talking about x. And let y denote the lesser of the two outcomes. So in 1 1, it's 1 again. What we are clearly seeing is that it is associating a real number with the outcomes, with the sample space, with the elements of the sample space, right? So this is all this is the table of these random variables, what values they are taking. Now, corresponding to these values, we will have some probabilities as well, right? What will be the probabilities? Since we are dealing with probabilities, that is what we are mostly concerned with, the probabilities, right? Suppose x is a random variable. This, now we have seen this x, this is the same x, that sum of the two rows. We know our sum goes from 2 to 12, right? Now, what is the probability of x taking value 2? What does that mean, x taking value 2? Can anyone explain?
The sum of the outcomes of two.
So basically, the way our random variable is defined is
Sum
x.
of the outcome is 2.
Sum of the outcomes is 2. That is how our random variable is defined. So corresponding to this, what is my probability? So I will see what my relevant
1 by
event is,
36.
right? Yeah, 1 by 36. So I will first see the basic definition, favorable over total cases, right? Favorable to this. What is my favorable event related to x equals to 2? It's basically this event, 1 comma 1, right? So I have only one outcome that corresponds to this, x equals to 2. So I know total outcomes whenever I roll 2 die. These are 36. So 1 over 36. Similarly, for 3, it will be 1, 2, 2, 1, 2 over 36. And we know how to do this, 2, 1, 3, 2, 4. All this will come from these favorable events over total events. Now, from this, we know the summation of these probabilities, it's always going to be 1, right? Basic definition of probability is that the sum of probabilities total, it's 1, right? So suppose this was, now we saw that x is equal to sum of the two events. Now, what if we had the lesser of the two values? What would we do then? How would we go about this? Then what we will see is that lesser of the two outcomes can always be 1, 2, 3, 4, 5, 6, right? 6 when both the outcomes are 6, 6. Okay. So this is just the table for that. I think it will be better if we take a question rather than this. So, okay. Suppose, just a moment. Oh, these are the just. This is for the lesser of the two. We know why until and unless all the outcomes in which I will have 1, my lesser will always be 1. So y will take value 1, 2, 3, 4. Similarly, it will take 4 when it's 4 and any number greater than or equal to it, 5 when we know the relevant outcomes 5, 5, 5, 6, and 6, 5. So this is how we are basically defining a random variable. So what we say is y is a random variable with which will take values from this 1, 2, 3, 4, 5, 6, and the respectively probabilities that we know how to calculate, right? We'll just see what is the relevant event divided by total events. For 1, how many events in which I will get 1 as the smaller one. So this I can see these are 11 by 36, 2. I can similarly calculate for 2, then for 3, 4, 5, and 6. I know basically it will only be when it's 6. So my favorable event is only 1 and my total events are 36. So 1 over 36. So similarly, we can see this random variable in many ways. Now, what is associated to the random variable is probability distribution. Probability distribution. What is this probability distribution? Can anyone tell me?
Corresponding probabilities of random values.
Sorry.
Corresponding values of probabilities.
Yeah.
For the
So-
particular random variable.
Right. What my probability distribution is? Basically, we take this is a table. In this table, what we see is corresponding to each value that my random variable takes. What is the probability corresponding to that? Probability of x equals to c. It means my random variable is taking value c. Similarly, my probability distribution, in the probability distribution, this is my x. Suppose my x takes values 1, 2, and 3. Then my probability related to, suppose this is a, this is b, this is c, right? So this table, what this table is, this is what is my probability distribution for this random variable. Now from probability distribution, I will get these probabilities. These are basically probabilities, and these are all the values that my this random variable is taking. So what will be my a plus b plus c?
1.
1 always, right? Because we know the summation of probabilities is always equal to 1. You've also seen many questions in the graded assignment or the activity questions in which we just had to solve for these, right? Sometimes we were given k, or sometimes it was not given. Suppose I give you one question. Suppose this is my random variable, probability of x equals to x. This is my random variable, and this is my probability distribution for this. It's 0.1 if x equals to 0. It's kx if x equals to 1 or x equals to 2. It's k times 5 minus x if x equals to 3 or x equals to 4, and it's 0 otherwise. Now what I am asking, what is the value of k? Is the value of k. How will you do, anyone? Take some time to solve this, then we will see how to approach this question. Just let me know what you all get your answer to be. Are you all solving this?
0.18.
0.18, okay.
0.15.
0.15, okay. I'll just write down one. I got 0.18. Another one was 0.15. Any other solutions? Anyone else solve this? Okay. Okay, there are some in the chat box as well. 0.15, 0.18. Okay, now let's see what this is. So my distribution
0.15.
0.15. Okay, 0.15. Let us see now what this is.
0.18.
0.18, okay.
0.09.
0.09, okay. So this is my random variable x, and I will denote what probability x taking value, whatever it is. Now, what my random variable is taking value? 0, 1, 2, 3, and 4, right? These are the values it's taking. Otherwise, it's 0. So we're not concerned with that. So my x is taking values 0, 1, 2, 3, and 4. So when it is 0, the probability is 0.1, right? 0.1. When it's 1 or 2, it's kx. So my x will be 1. It will be for 1, it will be k, right? For 2, it will be 2k because it's k times x. And my x is this 1 or 2, right? So it will be k or 2k. For 3, what will it be? 3 and 4, it will be k times 5 minus x. So for 3, what will this be? K times 5 minus 3. So it's 2k. And for 4, it will be k times 5 minus 4. It will be k, right? So it will be 2k and it will be k. This is my this table is my probability distribution. This is the probability distribution that this random variable is having, or it follows. So I know now I have to find the value of these k. I know the summation of probability is always going to be equal to 1, right? Plus k plus 2k plus 2k plus k. This will be equal to 1. When you solve this, your k will be equal to 2, 2, 4, 5, 6. Okay, it will be 0.15. Okay. As many of you just pointed out also that our k is taking value 0.15. Any doubts in this question?
No, sir. No, sir.
Okay. Now, suppose this k, this random variable x,
Sir,
what
hello.
yes.
If you scroll up back to the solution, the solution that you solved.
Okay,
So
here it is.
0.1 into 0, it would be 0, right?
No, we're not finding expectation. We're just
Oh,
calculating.
okay. We're just finding the value of k. All right. Okay.
Yes. We're not concerned with expectation right now. Now,
Okay.
suppose what this x, this I told you this is a random variable x. Now, suppose this random variable x, what it is, this random variable x, it denotes number or denotes number of hours a person studies. Okay. So what is the probability? If I were to ask you, what is the probability? Find the probability. Find probability that the person studies at least 2 hours. What will this be? Probability that the person will study at least 2 hours.
Probability
of x greater than 2.
Probably greater than 2.
So that will be basically probability of greater than equal to 2, because I'm asking at least, right? So my 2 will be there. So it will be basically this 2k plus 2k plus k, right? Basically 5k. Then substitute the value of k. It will be
0.75.
Yeah, it will be that 0.3, 0.75. Yeah. Now, what will be my probability that I study exactly 2 hours?
X is equal to 2.
0.3.
0.3, right? 2 into 0.15. What is my probability that I will study at most 2 hours?
Then x is smaller than or equal to 2.
Smaller
No.
than equal.
0.46. 0.4.
Will that be, are you saying this, it will be probability x is less than 2? This is what you're saying. Am I asking, is it so? At most, I study 2 hours.
No, x is smaller than or equal to 2.
Yeah, so basically it will be this, x is smaller than or equal to 2. So you need to pay a little attention to what question has asked, because sometimes we feel the question is too easy and we tend to make small mistakes, right? So
Yes.
Can you repeat the question, please?
Sorry?
Can you repeat the question, please?
So the question was that my x is a random variable which denotes the number of hours a person studies, right? So this was my this one marked probability distribution. From there, I found out the value of k. First, I asked what is the value of k, so that we could easily calculate, because summation of these probabilities will be 1. So from there, we found out k to be 0.15. Then
So
what,
there is one clarification. Whenever they say more than or less than, that time that specific value will never be included, right?
more, it's basically depends on the language of the question. Suppose I ask what is the probability that you will study more than 2 hours.
So what are you discussing? Can you go
Yeah,
from this one?
This is basically just a probability distribution. This is basics of that. Coming back to the question, yeah, it depends on the language. If they are asking more than, then yeah, you don't consider this too. Then you start from this. But if they ask at least or at most, then you have to consider whichever.
Included.
Yeah, whichever.
And if
point.
it is just less than, means only 0 and 1.
Yeah, so suppose it's less than 2, so you won't include 2. It will be 0 and 1 only, right?
Okay.
So that will be the case. So this was a basic question for this. Now, now we have seen that we calculate mean. So something in whenever we had this usual variables, we calculated mean, right? So something corresponding to mean, something like mean in random variables, what we call here, that is expectation, Okay, expectation or mean of a random variable. So how do we go about calculating it? So expectation or mean of a random variable, what you do, you multiply the value that the random variable takes with the probability and you sum all those. What I mean by that is it will be 0 into 0.1 plus 1 into k plus 2 into k plus 3 into 2k plus 4 into k. Okay, that is how we calculate the expectation or mean of a random variable, right? It's basically the summation of what my just let me scroll down, what my expectation of x is. It is basically summation of xi pi, right? I ranges from 1 to n, however how many values my random variable is taking. This is basically the value the random variable takes multiplied with the corresponding probability. Okay, it will be basically something like this: x1 p1 plus x2 p2 plus so on up to xn pn. Okay, this is my expectation of a random variable. Now let's discuss one question here. This is a pretty basic question. Suppose I throw a pair of dice, okay, a pair of dice is thrown. Now, as I already previously said, that the random variable that we are concerned with, it will always be discussed, or it will be given in the question. Only then we can work about whatever we have to find. And my random variable x, let x be the random variable. What is this? It is sum of some products. Okay, sum of these events. What is my sum of these the pair, sum of the dice? What is my expectation? I don't want an exact answer. I just want to know how you would approach this.
2,
1 to
3, 4, so 2
Expectation
to
is
1 to 6.
2 to 12.
Okay,
It will be
let's
from
leave expectation.
1 by 6
aside.
into 1 plus 1 to 6 plus.
What values will my x take?
2 to 12.
So 2 to 12.
2 to 12. Right? Then what we will do? First, we need to calculate what my random variable, what values it takes, right? So we know
Probability.
probability. How we will calculate the probability?
A
the
favorable
probability
outcome
of
by
getting
total number
two.
of outcomes.
Right. So for 2, it will be 1 over 36, right?
1 over 36, yes.
Yeah. For what will be for 12?
1 by 36.
1 by 36.
So like you all might have also noticed that whenever we are talking about this die, it follows a pretty symmetric this probability distribution, right? It will be 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, then it will decrease, right? It's something like that. Like I'll just show you if it's there. It might be a little useful when you are solving some questions, that it will save you a little time if it's here. Just let me get there. Slides of two. Yeah, can you see from here? This is what I was trying to say. This is somewhat symmetric.
Yes,
1, 2, 3, 4, then again 5, 6, then 4, 3, 2, 1. Okay. So what is for 12 and 2, it's same. For 3 and 11, it's same, right? For 4 and this 10, it's same. So it's not to worry about, but it's just something it might help you while solving the question some way. It might. So this was my expectation. Expectation is, now we've seen this is nothing but the mean expected value. We said the random variable, what my expected value of the random variable is. So that is nothing but just the mean. We have seen one example. Just a moment, let me roll it down to every word. Yeah, so this was the question, that a pair of die is thrown and x, I have to define what my random variable is, and I'm define my random variable to be the sum of the roll. And I know this will take values from 2 all the way to 12. Then how do I find the corresponding probabilities? I just see what is my favorable events related to this 2 divided by total. Similarly, all the way. Now, how I will find this expectation? It will be 2 into probability 2 plus 3 into whatever probability it takes plus 4 into whatever probability it takes, all the way up to 12 into the probability it takes, right? The value I get from there, this will be my expectation, okay? So this is how we calculate this expectation from, then after expectation, we, let's see what is there after expectation. So this probability distribution function that I just discussed, it's also known as probability mass function, okay? Probability mass function. PMF, that we denoted by PMF. Sometimes you might see it as probability distribution or sometimes as PMF. They both basically refer to one of the same things. This PMF, what it gives me the probability of the random variable taking a particular value, right? Whichever value it is taking, it gives me the probability of that, that only. Okay. Now we have seen some questions. Now, what is my, let's so this, now I have this, let's suppose this is my X and this is my probability of X. This is nothing but, suppose this is this 1, 2, 3, 4. This is 1 by 8. This is 2 by 8. This is 3 by 8. This is 2 by 8. Is this a valid PMF?
No, sir, this is not.
This is not a valid. Why?
Yes, sir. Valid.
This is valid,
Because
sir.
the sum
Valid.
is not one.
Sum becomes 1.
Sum becomes.
Sum is 1. I think sum is 1.
Yes, sir. 1. Valid.
Yeah.
Yeah, so it's valid
It's valid, right? Now,
and
here
everything is possible.
yeah. So what I want to discuss here is, suppose we were to now draw a graph for this probability mass function. How would this look like? Anyone?
Bar graph.
X on a like
Skewed graph, positive, skewed, negative, skewed.
No, I'm not talking about skewed, but I'm just talking about what type of graph I will get here.
Bar graph.
Bar chart, right?
Yes.
So on this bar chart, what I will have is, just a moment, this will be my bar chart. On the x-axis, what will I have on the x-axis?
The value X
Random
can
variable.
take.
The values of x basically, right? What will be on my y-axis?
The probabilities.
Probability.
0 to 1.
X is equal to xi, whatever this is. So suppose my x is taking values 0, 1, and 2. It will be something like this, right? Something like this. Whatever this is, you know, these values corresponding to this, this, and this. These must add up to 1, right? Because my probabilities are always 1. The summation of total probabilities will be 1. So this will be the graph. Now, what the behavior of the graph is, we will also see in the upcoming slides. Okay. Now, this is for this, yeah. Then what we have is cumulative distribution function, what we call as CDF. Can anyone explain what this is? Cumulative distribution function, or what we denote by capital F?
It is continuous function, sir.
CDF, PMF. These are basically what we have for this. Like first, we are discussing
Sum of probabilities up to a particular point.
Yeah.
It gives the probability for an interval.
Interval, okay. Interval, basically, when we are talking about interval, what we say is it gives us the probability of the random variable taking a value less than a particular value, right? It will give us the probability of it taking the value less than a particular value, okay? So, it is denoted.
Less than and equals to.
Yeah, no, not yeah. It's taking the less than, yeah. Basically, it will, whenever we will be concerned with, it will be less than, okay? So cumulative distribution function, how is it different from PMF? PMF gives us value at a particular point, right? At a particular value. What is my probability at a particular value? And in this case, we've seen it's less than. So how we denote it? It is denoted by f of a. Suppose this is a is my, what is my a? This is my value that the random variable is taking less than or equal to probability of x taking value less than equal to this a, okay? So this is a, the value the random variable will take, value of random variable. So what is my what will be my f of a? I know what is the range of f of a be always be
0 to 1.
0 to 1. Right, 0 to 1. We've seen this in the lectures also. Ma'am has explained it that okay, this will be 0 to 1. What will be my probability of minus infinity? These are some properties.
0.
X 0. What will be my probability of x taking value infinity?
1.
1.
1. Can anyone explain why this is 1?
Because the maximum probability adds up to only 1.
Yeah.
So
Or
whatever be
what?
the limit,
Mhm.
it adds up to 1, right?
Or whatever I can, in other words, I can say this is equivalent to saying probability of x is less than equal to
Yes,
infinity.
x less than equal to a, so it will be x
Yeah.
less than equal.
It will always be 1, right? X, and whenever I say probability of x is less than equal to minus infinity, we know this as we're considering right now, it will be 0.
0.
Okay.
No, hold on.
Excuse me,
For x less than equal to infinity,
Yeah.
it can take any value less than infinity, right?
Infinity, I'm today talking about probability of.
No, correct. And x is my random variable. So here we are saying what is the probability of my random variable
Mhm.
taking any value less than or equal to infinity, correct?
Right.
Right. So is it possible? So that includes all the possible values from 0 or minus infinity to infinity, basically. Right?
Basically, what it includes is all the values that what we are trying to say here is all the values that this random variable takes, right? Suppose my random variable takes 1, 2, 3, 4 only, right? For 5, 6, 7, 8, minus 9, minus 10, whatever. This will always
All right.
be
Okay. Got it.
So this was for now.
So can you please repeat what did you just say? I was like my
It was
network is
basically,
kind of.
yeah. What they were saying is, suppose this probability of x is less than equal to infinity, it will also contain other points, right? It will contain infinite points. But what my argument was that my x will take only these values, right? And for other values, suppose this is taking only on these values, it has some probability. For other values, it will be 0, right? As it's
So,
also mentioned.
Yes.
So if my random variable takes values 1, 2, 3, and 4, for example,
Yeah.
can I say 3 is less than or equal to infinity?
3 is less than or equal, probability of x is less than or equal to infinity. 3,
Yeah. So if
probability of
p
x,
is less than
sorry,
so x equal to 3 less than or equal to infinity.
f of 3, you are basically talking about this f of 3. What does
Yes.
this mean?
I mean,
It's not x is less than in 3 is less than infinity. It's x is less than 3. This I was taking f of infinity.
okay. No, the one that you have written next to it, right? Probability of x less than or equal to infinity.
I was
one next to.
What I was saying is this f of infinity basically translates to this probability x taking value less than whatever is mentioned here. Okay.
Okay.
So when I have f of 3, it means value taking less than f 3. Okay. Now one question here. We've discussed the graph of this PMF. What will be the graph of my CDF?
Step function.
Okay. Step function. So why would this be a step function? Like we've seen, what is this step function at? It will be something like this. Sorry.
Because from 1 point to 1, another point, it adds up
Because
the
when we
value.
plot it, behaves like a step.
Yeah. Basically, it
This is
goes
the high
something.
difference.
Yeah, it will go something like this, right? That we've seen. And suppose I want to calculate the value of this particular point. What will be that?
Will be the probability.
Yeah, it will be basically the difference of these sizes, right?
Yes.
This value minus this value. So that is about this CDF. There isn't I don't think there is much more to discuss about the CDF. These are just, there are a lot of questions that will also take a few more questions. Before coming to the question, want to cover up all the topics, then we can take the questions together. Okay.
Sir, can we write PDF from CDF? I mean,
sorry.
Can we write see, we always write CDF from PDF, right?
We always write.
See, we develop the CDF from
Okay.
probability distribution function, right?
We write this PDF from this probability distribution function. Okay.
Yeah. Can we do it the other way? Like
You
from
can. That's what I was saying. These particular. What is my this PDF? What do I have? The probability of X taking a particular value, and I just said
that's right.
if I have to see what this particular value is, I just take difference of these steps, right? So
Yeah,
I
that's
can
right.
that way. Okay. From the step.
Excuse me, sir.
Sorry, someone saying.
Excuse me, sir.
Yeah.
Yes, sir. One question regarding this graph. Could you please go to previous slide?
Previous slide. Okay.
What you explained, sir? What you explained, sir?
No, I was just discussing. I was just asking
Yes, right. This one, sir. This one only.
What I was saying is what the graph of my CDF looks like.
I understood, sir. I have one question regarding this.
Okay.
Sir, there was one question. In this graph,
where was
including the CDF, these horizontal lines.
Sorry,
in this graph, sir.
Your voice broke in between. Can you please repeat starting?
Hello, sir. Hello, sir.
Yeah, now it's clear.
Sir, in this graph, what you have shown, these horizontal lines are showing CDF, no? And dotted vertical lines are showing this here.
No, this is showing my f of a. This is showing my
X, and this is showing my f of a, right? The vertical line.
So what is probability distribution? This is showing this dotted vertical lines.
No. This value it takes. This is basically what I tried to show is the jumps, the steps. How this
right.
Step.
Sir, if we are going to be going for this CDF, this dotted lines are not required.
No.
There was a question in there. Okay. Understood, sir.
Okay.
Sir, dotted line can be represented as PMF, no?
Yeah, that is what I was.
Difference between
this difference between these steps, that is basically this dotted line only, right? If you see this is one, right? This is the other there. Difference between those two is this dotted line. Was that dotted line that was previously dotted,
Sir,
right?
I was only asking for the graph of the CDF.
Okay, yeah, sure.
In that only this dotted lines should not be there, right?
No, they don't necessarily have to be there.
If it is there, sir, then the graph is correct.
It's not. The graph is correct. Why is it incorrect? It's just showing some like jump.
Because there was one question in this activity course.
Okay.
Where these two lines were available, both vertical and this horizontal. But the option was for that this horizontal lines.
So it would have been something else. Basically, these what I draw those dots. They were just to show these jumps. You don't need to draw them because what we are concerned with PDF is this one only, right? This can, what I am trying to say, this can be there for the help of reference, showing these jumps, but it's not necessary that
both these options were available in the answer.
So
in
that
the
would
options,
okay,
including
Maybe
the graph,
maybe
including the graph,
maybe
including the
vertical line.
vertical and horizontal line. But the answer was the only with the graph having this horizontal line.
Okay, so it's better if like to avoid these vertical lines, and I did not draw those as lines. I just draw those as these dotted points, right? These were not lines. I was trying to show that there is jump. So coming to next thing.
Sir, 1 second, sir.
Yeah.
Can you just tell me about that right skewed, left skewed, and symmetry?
Yeah. We will get to everything.
Okay, we are getting to that. Okay.
Yeah. So just like we'll discuss first. We'll take up all the topics that are covered. Then we will discuss the questions. Okay. We'll just brush up a little on these topics, whatever topics there are. Then we will get towards these questions. Now, coming to next topic that is there is variance. So what is variance? Anyone?
Sir, EX square minus EX ka whole
It's a
square.
measure of dispersion.
It's
Measure of
basically
spread or dispersion.
dispersion or spread. Basically, it's that. So Okay, before coming to that, I will first discuss a few properties of this expectation. Okay, properties of expectation will come. Properties of expectation. This is really important. These properties of expectation and properties of variance, these are really important. Like I've seen direct questions come in the quizzes from these only. Okay, so be a little careful about these. So if I multiply, suppose my g function was g of x. If I multiply it by some constant, suppose, what will be my expectation, new expectation? A times x. I multiplied the random variable with some constant. What is my expectation of g of x now?
It will be
A
A
into E of X.
A times expectation of x, right? It will just be multiplied. Now suppose my g of x is something like this. G of x is equal to a times x plus b. Now what is my expectation of g of x?
A times
A times E of X plus B.
A times E of X plus B.
Yeah, yes. So basically these are the two properties that we have for this expectation. There are we'll come to variance also. There we'll also see some other properties, but these properties I'm saying these are really important. Okay, these properties, be it from expectation or from variance, these are really important. Okay, so we'll also discuss some questions about regarding those now.
Sir,
yeah.
Sir, why we add plus b, ax plus b?
So how it's done, it's basically discussed in detail in the lectures. So if you want, you can refer there. But it is something similar to, yeah.
So what if we have to do like x plus 1 a whole square? Then what we have to do in that?
Okay, we will come to that as well. Okay, x plus 1 whole square. We will come to all those questions as well. First, what I was trying to say is, if we are multiplying by a constant, the expectation also gets multiplied. If we are adding a constant, then it will also get added to the expectation, the constant. Okay. Now, suppose coming to that question, we had this x. Suppose my x is taking values -1, 0, 1. Suppose now somehow my random variable is defined as this x square. So the probabilities, suppose related to these is A, B, C. Now, when my x square is happening, what I will do is I will just square this x values. Okay, it will be 1, 0, 1 only. Suppose let's take this 2. So it will be 4. So the probabilities will remain same. The probabilities corresponding to these x and x square will all remain same. Okay. Now, why do I need this? Why I've shown this expectation of x and x square? Because one important point I want to note here, expectation of x square, this x square, right? It will now have its own probability distribution, right? This will be its probability distribution or PMF. Then from there I can calculate its expectation. Expectation of x square is not equal to expectation of x whole square. Okay, it is not equal to this. This is really important, because from this we will, now that we have covered variance, we know where we are going with this, right? So this you need to be mindful of. Expectation of x square, this is not equal to expectation of x whole square. After this, what comes, there is one more property, like expectation of x plus y. What is this equal to? This is basically equal to expectation of x plus expectation of y.
So when both are independent.
No. Here it doesn't matter. If both we have two random variables, we have variance. Yeah, that is variance. For variance, that is right. This was a question also. It will also hold if there are more than two variables. Okay, expectation of x plus y is equal to x. Basically, sum of expectation is equal to expectation of sum. Okay.
So as it was mentioned earlier, Abhi, you just mentioned that when we are calculating variance, so ex square will not be equal to ex to the whole square. So, but when we want to calculate like expectation of x square, how are we going to get that if the variables are not independent?
Expectation of x square, that doesn't matter. For me, what matters is my x will be given, right? What I will do is I will basically square those x values, and probabilities related corresponding to x will be given. So that is all.
So we can calculate it manually here.
Yeah, definitely. That is how you are going to approach it. You just square this x the probability given related to x will be corresponding to x square as well. Then what you have to do is 1 into a plus 0 into b plus 4 into c.
Yes, sir, got it.
That will be your expectation of this. Now, suppose let's take an example here. Just suppose let my x be a random variable outcome. This is outcome of a fair die.
Hello, sir.
Yes.
Hello.
Yes.
Sir, our x is taking now x square, but the probabilities remains the same, right?
Yeah.
You explained before.
Yeah, that's what I told. Yes.
Okay.
So suppose this is my expect x be the outcome of a fair die, and dice. Okay, and this is from another dice. What will be my x? What values will my x take? So basically 1, 2, 3, 4, 5, 6. And what will be my probability is 1 by 6, 1 by 6, 1 by 6, 1 by 6, and 1 by 6, 1 by 6 all the way. Similarly for y, I will have the same distribution, right? Now my expectation of x, what will be my expectation of x? It will be basically into 1 by 6 plus 2 into 1 by 6 plus
1 by 6 into 1. Summation of 1 to 6.
7 by 2.
N plus 1 by 2.
Yeah, n plus 1 by 2, right? Now that we have seen something similar, we have seen something like this, n plus 1 by 2, right? What it is, you know what it is. We will come to that also, but we have seen this. So this will be my 7 by 2. Similarly, my expectation of y will also be 7 by 2. Now, what will be my expectation of x plus y? This will be equal to expectation of x plus expectation of y. That will be equal to 7. Okay. Now, what I want to give here, if I have 2 dice, if I throw 2 dice, right? Because this is basically equal to 1 dice plus second dice. Okay. If now let's calculate what is sum. This is basically that when I throw 2 dice, my x will be 2, 3, 4, 5, 6, all the way up to 12. And corresponding to this, I will get 1 over 36, 2 over 36, 3 over 36, all the way up to again 1 over 36. When I do this calculation, 2 into 1 by 36 plus 3 into 2 by 36, you will see the value that you get is equal to 7. So hence, this is proved, this property that we had, expectation of x plus y is equal to expectation of x plus expectation of y. Okay. So this is how as well. Now, just a moment. Now, coming to variance, we want to first we'll discuss these all. Coming to variance, what is my variance? Why did we calculate variance in the first place? Like we also calculated it in the previous case, right? What was
for showing
Find the
difference, sir.
dispersion.
Yeah. So
To
basically,
get a value of dispersion.
exactly. So basically, what we saw there as well is sometimes we had 2 different data sets whose mean, median, and mode somehow came to be equal to same, right? Then what we would consider these 2 data sets are same, but in fact they were not same. That we have already seen like week 1 to 4, right? So how do we differentiate? So to differentiate, what we go is we will go to variance. Variance is nothing but it's spread, the variability of the data. Okay. Now variance, how we denote variance of a random variable? It's variance of x. And what is it equal to? Expectation of x square minus expectation of x whole square, right? What you might also say is it will be equal to expectation of x square minus mu square. Okay. Mu is basically expectation, right? Mu is mean. We have already seen in week 1 to 4 what that we used to denote our mean by mu. So following the same convention, we can write mu. Okay. So it will be mu square. Now, suppose I tell you this question. Is there any space?
Sir, I have a doubt in this. Can I ask a question?
Okay.
Suppose variance of x is given 2 and variance of z is given 7, right?
No.
And we have been given as equations which says y is equal to 2x.
Equal to x, y equals to 2x. Yeah.
Right.
This is a
Now
from this activity question, right?
Yes. So then we have to calculate the SD of x plus y plus z. So for that, we have to calculate first variance of x plus y plus z, right?
what you do basically, since your y is given to be equal to 2x, just substitute it in there. You will get your answer pretty easily. You can go by that method as well, but that in that method you will get one additional step. But the moment you put y equals to 2x, since it is given, right?
Yes.
You will get your answer in much simpler ways. Okay.
But sir, if y is equal to 2x, it means y and x are not independent, right? So
No,
still when I use this-
y and x are not independent. Then it was something like this: x, y, and z, something, right? When you substitute your y equals to 2x, now what is left with me? X and z only, right? But
Yes.
it was given that x and z are independent, so I don't need to care what y and x are internally. I'm only
Sir,
considering with x and z now.
Then it will be 3x plus z.
Yeah, definitely. This
Okay,
going on.
okay, got it. Thank you, sir.
Okay. Now, my variance, what did we say it is equal to? It's equal to expectation of x square minus mu square, right? This is basically mu is expectation of x whole square. Suppose, let's follow from our favorite example again, this rolling a dice. What is my variance? X is the outcome of the roll. What is my variance? My x is taking the values 1, 2, 3, 4, 5, 6. What is my x square now? It will be 1, 4, 9, 16, 25, 36. What is my probabilities? It is 1 by 6, 1 by 6, 1 by 6, 1 over 6, 1 over 6, and 1 over 6. Now to calculate variance, what will this variance be equal to? This will be basically equal to expectation.
N square minus 1 by square.
Right. It will be basically, we will calculate expectation of this first. This will be my expectation of x square, right? Then I will calculate expectation of x, sorry, just a minute. Expectation of this x, and I will square that, and I will take the difference, and it will give me my variance. Okay. That is how we are getting this variance. Now, what is a Bernoulli random variable? Can anyone tell me?
Which has only two values,
Sir, hello. Sir, I have one question, quick question.
Okay.
Can you go back to that variance formula?
Yeah, sir, please.
Yeah.
The initial formula, x, not this one. So,
okay, I will write it
minus.
again. I will write it again. Expected variance of the variance we're talking about. Variance is basically.
Yeah, basically it's expected value of x minus mu the whole. No, that's not this. X minus. It's x minus mu the whole square.
Okay,
right?
the basic
that,
variance of x. You are talking about this expectation of x minus mu whole square, right?
Yeah, I had some questions, like conceptual questions on this. Like, why do I have to take an expected value of x minus mu? Like, why can't, basically, if we think about the way we calculate variance in case of like other values, right? Not in terms of
other values. By other values, you mean?
So those are deviations.
You take a sum. Hold on. We take a summation of x minus mu, and we can multiply it by the frequency, which is going to be the probability. So if we do that, do we derive the same formula?
You are saying we will go by the approach in which we have derived it for, like we have seen already in week 4, right?
Yeah. If I do that, will I come to this formula that is expected value? Basically, that I mean, both are same when you think about it. The probability, in case of probability, we are putting probability, and then we are calculating this variance, and the n value will always be 1.
Yes, my n value will be 1. We are calculating this variance. So you are saying is, if I approach it, the formula, basically the derivation of the formula, in that way, will I get to that? So I don't know if you will get to that. I'll have to check that out. Okay. As of now, I don't. I just know the approach. If it is there, you can post it on discourse or discussion forum. I will let you know there. Okay. Now coming. Yeah.
Sir, I had a small doubt on variance. And like, sir, if we have 2 or 3 dependent variables, then how will we calculate the variance?
We will come to the questions. As I just said, first I will just touch these topics a little bit, then I will come to questions. Okay. Okay. Now, what is my Bernoulli random variable? Anyone?
So Bernoulli random variables are those which can take only 2 values, 0 and 1.
Yeah, suppose my X is a Bernoulli variable, it will take value 0 or 1. I can encode this as failure or this as success, right? Whichever way I want. Or I can do the opposite, this as success and this as failure. So what suppose now there is one good thing when we have this Bernoulli. My probability, suppose this the probability
Be
for
independent.
yeah, this will be 1 minus p, right?
Yes. 1 minus p.
Yeah. So from this, my expectation, what will be my expectation? 0 into 1 minus p plus p, right?
Yeah.
So my expectation of p is only expectation of p. And what will be my variance in this case? What will be my variance? Yeah, it will be
P into 1 minus p.
Yeah, it will be x square will be again 0 and 1, right? P is 1 minus p and this is again p. So it will be again p minus p square, right?
Yeah.
Expectation of x square minus expectation of x whole square. Okay, so these were some basic formulas for this Bernoulli random variable. Now there is my another random variable.
Hello, sir. Hello.
Yes.
Binomial.
Sir, why are we not taking probability of 0 is p?
We are taking that is depends on the convention. You can do that as p and the other one as 1 minus p, but then you'll have to follow this convention throughout, right? This is just convention I'm saying. Okay, mostly what
because if we take 0 for probability p, then 1 is 1 minus p, then expectation changes. Expectation changes to 1 minus.
Yeah, that
1 square minus 1 will become 0.
Basically what it happens is if you're taking this probability p, this will be 1 minus p, right?
Yes, sir.
So it will be 0 into p, it will be 1 minus p. So as I already said, it depends on your convention, what you are taking as success, what you are taking as failure. You can do that way as well, but what we are doing is we are following this convention only. Okay.
Okay, sir. Okay, sir.
Now, what is my this uniform random variable? Can anyone tell me?
So it's
It
like
takes value 1,
When
2, 3, 4, 5.
probabilities of each
Random
x
variables
is
are
same.
there, then a probability is 1 by n.
Like there are n events, so a probability will be 1 by n for all the events.
Can you give me an example?
Rolling like rolling a die for once.
Tossing a coin.
Right, tossing a coin, rolling a die. Basically, wherever we have this, what I say, equally likely event, right? Equally likely, where I am having something like this 1 by
Equally
n.
likely outcome.
Yeah, equally likely.
Sir, does the value of the random variable also need to be like value from 1 to n, like discrete value from 1 to n, like 1, 2, 3, 4, 5, 6?
It will
Can
only
it be
then,
like 2?
it will only then.
Can it be?
Then
Sorry,
only.
can it be like?
Sorry.
Can it be like 2, 4, 6, 8, and 10, and with each of those probabilities as 1 upon n? In that case, also can we call it like a uniform random variable?
2, 4, 6, 8. What is my n?
Yeah. Or in this case, n would be 4.
It will be 1 by 4, 1 by 4, 1 by 4, 1 by 4. If they have to be discrete uniform random variable, okay? What this x
So
is,
in this case, can we?
Yeah, this is a
Can we
random.
still call it uniform random variable? Okay.
Yeah, it's not depend on this. It depends on this. Uniform random variable means my probabilities throughout of whatever this takes. Because I don't know when you are saying 1, 2, 3, 4, then we are somewhat thinking like dice. The first one appears, 2 appears, so it's somewhat that. But it's not that. We are not considering.
The reason I asked this question is because while calculating the expectations, right, you have actually use the formula for the sum of first n numbers, and that's how you come up with n plus 1 upon 2. So that's why I asked if it's not first n numbers, if it's some discrete random values but equal probability, does the formula still hold?
So basically, then you will have to go for your, like, you have to see what my expectation is. Your expectation will not be. Suppose when you're taking 1 to n, only then we are using that formula n into n plus 1 over 2n plus 1 over 6, right? Here, then what will be my expectation? 2 into 1 by 4 plus 4 into 1 by 4, right? Plus 6 into 1 by 4. You can always come to, whenever in doubt, whenever you forget a formula or whenever in doubt, you always have your basic tool. That is your basic formula, and that's not too difficult to come back to, right? Value into probability, value into probability. You can go there, right?
Okay.
my for this uniform random variable, if my x is taking values from, as someone was just saying, I didn't catch your name. So x is taking from values 1 to up to n, and my probabilities, my x square will be also from 1, 4 up to all the way up to n square. My probabilities are somewhat like this, equally likely. In this case, what my expectation is? What is my expectation?
N plus 1 by 2 into 1 by n.
It is 2 into 1 by n. I can see I can take this 1 by n common throughout, right? Then it will be basically sum of first n natural numbers, right? From there I will get it equal to n plus 1 by 2. And similarly, my variance I can calculate, that will be n square minus 1 over 12. These are, yeah. Yes. Am I audible?
Yes, sir.
Okay,
Yes.
okay. So now let's first dive into the properties of
So now it's so that formula, right, which was what I was asking. Now that looking at that formula, it seems that it, because it's n plus 1 by 2 and n square minus 1 by 2, it seems that it is independent of the random variable values. Rather, it is more dependent on the number of values the random variable
that
can
the
take.
variable takes. So coming to my next properties of variance. Now we have discussed these variance. Now let's see these properties of variance. After this, we'll start taking questions on these. Okay. What is my first property? Can anyone just tell me? Okay, I will just write this variance of k. Suppose cx. What is this equal to?
C square variance of x.
So if I say variance of cx plus d, what is this equal to?
Then same C square variance.
Still C squared variance.
C square variance of x plus d.
Yeah. So it was something you could have related to those early when we read variance, that there was no effect of addition, right? Something, little familiarity. Just a moment.
Standard deviation.
So from variance, I can definitely get standard deviation. What is my standard deviation? What is standard deviation is? Can anyone tell me?
Root of variance.
Square root of variance.
That is not much difficult. If you know variance, you know what my standard deviation is going to be. So here I want to ask one question, an important question rather. We have seen this. What is this equal to?
Expectation of x plus expectation of
x plus e of y.
So what is this equal to? What is this equal to?
If independent, it will be similar.
Variance of x plus variance of y.
Variance of x plus variance.
If independent, sir.
Yeah,
Yes,
provided
only
when
those are independent.
Only when it is independent.
Independent, right?
Why, sir, only independent?
Because then it's changing. How it is changing, that we are not seeing, I think, in this course. But in this, like whatever we are seeing, it will be independent. Okay.
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 So just one question. Earlier one, you have mentioned when x and y are linearly related. If they are related by quadratically related, say variance of ax square plus bx plus c, what will be the variance?
Variance of
ax square plus bx plus c.
Ax square. Then you don't have to calculate. You have to calculate where you are.
So instead of cx plus d, let it be ax square plus bx plus c. Then what will be the variance?
Ax square plus
bx plus c.
Bx plus c.
Yeah. What will be the variance of this?
What will be the variance of this?
Yes.
What do you think? What will be the variance of this?
So we can second part we can do b squared times variance of x. First part we can do a square of variance.
But
but ax square, x and x, they are not independent, right? Can we split it like this?
Yeah, we can split these two parts. We can split.
X
square. But x square and x.
Yes, exactly. Are x square and x independent?
No, they're not independent.
Yeah.
That is where the catch is.
Yes. So then how will you do this? Should we make this as a whole square or in a linear form?
Like if we are going to, if something like this is going to be asked in the question, something like a complex this, you will be given some variables that are very like that are independent. Suppose that was given y is equal to 2x. It was x plus y plus 3z, something like that. And
So
your
what
y
you
was,
can do this, we can write this ax square plus bx plus c in the form of, say, variance of x minus alpha into x minus beta. So if I do this, this is a product of two parts. So x minus alpha into x minus beta, where alpha beta are the two roots. Can we do in this way?
you don't need to dive there, because what we are getting here is variance of x square, right? Variance of x square is different. It's something different from this x. When I'm considering x square, I am going somewhere else. I'm not just I'm not here now with the x. I'm not dealing with x. I am going into a different space of x square, because then if my variance of x square, what is my variance of x square? It will be expected.
So in case the bx is, if the bx part is not there, if you have only variance of ax square, can you do variance of ax square?
Then what do I have to do for variance of ax square? It's pretty simple, right? What is this?
That's what I'm asking. It should be a square into variance of x square.
A square into
variance of x square.
Then I have to, but for variance of x square, I have to do something different now, right? It won't be same as variance of x.
You can replace
x by x
variable
square
called y. No. You can replace x square by a new variable y, and now you have to calculate the variance of that y.
That can be done. That can be done.
That's what I am saying, right? Now what you have to do, you don't have to calculate for x, you have to go for x square, right? You have to go back to your this expectation of x.
So for this, you have to find first expectation of x square.
Then it will be variance of x square. Now you are saying, right? What will this be equal to?
Expectation of x
square power 4, right?
So it will go to ex to the power 4.
Ex
to the power 4 minus ex square
whole square. It will go that way. Okay. So what we are considering in this, at least in the statistics 1 course, you won't be like asked in much depth, or even if it is asked, it will be pretty simple. Now we have seen this expectation. Now standard deviation we have seen. Okay, let's what is my standard deviation of x? If my it's basically under root of variance of x, right?
To clarify, also the expectation will we also for expectation we are considering both to be independent variables, right? When we say e of x.
No. It doesn't matter. It doesn't matter here.
Okay.
It doesn't matter.
Okay, sir.
So what are my properties of, now let's discuss a few properties of standard deviation.
So quick question on this, on standard deviation. Does a standard deviation always need to be positive?
Standard deviation, can you have this, if I am taking this root, can it come to be negative?
Usually you put it as plus or minus x, right? Whenever you take a root.
Plus minus, we are, No, we are talking what we are doing.
It is positive square root variance.
Positive square root, right?
Like
because
variance is always square, no?
Right. Because that will be there, right? It can
so
never.
If variance, for example, is 25, for example, root of 25 is plus or minus 5, right? So I just
standard deviation. It's the square root of variance, right? Which is So it can't be negative, right? Since it's square from their base. Now, what is my standard deviation of CX?
C into variance.
Standard deviation.
Right?
C into E of x.
How did I get this? It will be basically C square variance of
C
x
square.
whole root. From here, I will take C under root variance of x, right? So these are my few properties that I need to know about this variance and expectation. Now let's come to a few questions. Okay, just a moment. Okay, just a quick and easy question. I want you all to solve this question. It's a very easy question. Yeah, I want you all to solve this question.
Sir, how many times is this dice rolled?
This is rolled a lot of times. This is tired.
$35 by 12.
Okay, I've got one solution. 35 by 12. Another, anyone else?
Same answer, sir.
35 by 12. Okay. Anyone else solve this?
Sir, what is the value of n here?
What is the value of
n?
Do I need
How many
n? Once. On a throw, right? On a throw.
Okay. Okay.
So it is 12.25.
Okay, is everyone satisfied with this? Because this is the solution. So, just a moment.
Yes.
Is everyone getting this? Because this is the solution for this question.
Yes, sir.
Anyone getting a different answer? Don't think so. This is pretty simple forward question, right? Is everyone done with this? We'll just move ahead. Okay. So
just it will be expectation of ex square minus like this, no?
Yeah, it will be basically that expectation of x square minus expectation of x whole square. Okay. It will be that only. It won't be anything.
91 by 6 minus, yeah, okay.
So there is one question I will take. Okay, this will be here. 35 by 12 is your answer for this. Basically, you will just calculate your x, then you will see your x square. What is basically my?
So, sir, it is uniform random variable, right?
Yes, it is uniform random variable.
Yeah. So we can use the formula n square minus 1 by 12.
Yeah, that's what I told. You can either use the formula directly, or if somehow you forgot the formula in the exam, you can always go with your basic, right? 1, 2,
Which
3.
formula, sir, n square into?
Sorry?
N square minus 1 by 12. N square minus 1 by 12.
So, suppose there is one question, or this is, you all must have solved this.
Hello, sir.
Yeah. Yes.
Will you discuss a graded assignment question from week 10?
We will discuss. I will see if time permits. I will discuss that as well, because yeah, I think I will take a few questions from there. Okay.
Okay, sir.
So this is, I think, from the activity or
that's what
question.
That's what you all must have gone through.
I tried this. Does this one involves a lot of calculation?
But like hypergeometric, if used, then it will be easy.
Yes, exactly. Like I also mentioned it in the previous session, and I've always been mentioning it. Like in the previous in the week 8, 9, week 8, 9, 10, you will be solving questions from these distributions only. But if the difference will be in week 9 or 10, you won't be knowing right which distribution we are using. If you approach this from hypergeometric, it will be a lot easier, right? Somebody just said that they have used hypergeometric. That is a very good approach for this. That actually makes the calculation a lot easier. Isn't
3 will be answer.
3.
yeah, definitely the answer for this question is 3. But I want others to solve this as well.
It's 5 into 12 by 20. Right.
Sir, I approached this question. I told you that day, sir.
Yeah. I do.
I approached this question in a very simpler way.
Yeah, I will do it in that way only. When we will come, we are yet to cover hypergeometric, right? When we will cover into hypergeometric, I will discuss it in that. We will discuss it in that way. Okay. So for those who want the simpler approach to this, and then they will see how hypergeometric is making these calculations easy. I will show you how this will be done. Let X be the number of women promoted. Okay, number of women promoted. Just let me keep a note here. This is,
is this using hypergeometry or without using hypergeometry?
This is without using hypergeometric. From the concept, I will just assume, because we haven't discussed hypergeometric. We know hypergeometric, but in this session we haven't discussed hypergeometric yet. So I will go with the basic method. Okay, the simple.
Is there one more session, sir?
Day after tomorrow, yeah, we'll have this previous end term solving. Okay.
Okay.
So today we will complete up to week 12.
Week 12, yeah, we'll definitely complete up to week 12 and including this geometric distribution.
Yeah, and please, okay.
Sir, I like to ask something.
Sorry.
Actually, there's some chapter in week 12, additional.
You don't need to go through those. You don't need to go through those.
Huh?
Sir, you will discuss geometric now.
Yes. We'll discuss geometric. You don't see. Well, I will write there here. No need to go through
additional content.
Okay.
Content.
Thank you so much, sir.
Just only for geometric, no, sir.
For end term, okay. But for stats 2, you need to go through those, okay.
So, but in additional geometric
only geometric, and we will be discussing geometric in a while. Okay, because in the mail
also has been given regarding that, right?
Yeah, that's what I am saying. In the mail also it was mentioned that geometric from additional contents will be discussed, but in additional contents there is not geometric distribution, right? So yesterday also I put a link which was for this geometric distribution. I gave you all the link from where you can study. Now today what we will be doing is in some time we will be discussing this geometric variable, geometric distribution, and we will solve questions regarding this as well. Okay, we will try to focus more time on this geometric distribution towards the later half of the session, because it's not discussed there in the lectures, right?
For this week 11 and week 12 graded assignments, the solutions are not uploaded actually.
Yeah, I have concerned that like I saw that concerns, and
no solve with us for week 12 also.
Week 12 there was not solved with us. I think there was solved with us for week 12.
The graded assignment solutions actually we need it urgently, sir. Actually we had hardly 2 days.
Yeah, I have already forwarded it to the team.
It's on the portal. I checked today. It's gone.
Is it uploaded?
Yeah, it's done. Sir.
Okay.
It was done in the morning.
Yeah, I told them so. Now let's.
So also, sir, that n square minus 1 by 12, that is applicable for which expectation, sir?
Sorry?
That is n square minus 1 by 12, the variance.
That is a variance formula. That is uniform distribution.
Uniform distribution, that is for
okay.
Okay. Now coming to this question. My question was, where is my question? It's lost now. Just a moment. I forgot the question.
Number of women getting promoted out of 12.
20. There are 12 women. Okay. okay, what can happen is either no women will get promoted, either 1 or 2, 3, 4 or 5. What is my probability that no women will get promoted? That will be all 8 men. There are 8 men. Only 8 men will be promoted, right? I will choose 5 men from the 8 men. Total, I have to choose from 20C5, right? Here, what will happen? 88, 4 women and 1 man. 8C4 and 12C1. Here for I will just write it separately. It's getting a mix. For 2, it will be 3 men and how many women? 2 women. For 3, it will be 8C2 into 12C3. For 4, it will be 8C1 into 12C4. For 5, it will be 8C1 into 8C0 into 12C5, right? This will be my this favorable. Total is 20C5. This is there is a lot of calculation, I think, in this question. When you will solve this, you will get your expectation to be equal to 3. Okay, this is a little lengthier calculation, but this will give your value to be 3. Now, coming to one more question after this. Just a moment.
Sir, can you also explain the other method that we use?
I will. This is basically that is this only, right?
Hypergeometry.
Oh, did someone use any? Which method did someone else was saying? I used a different method.
No, we solved this by using by hypergeometric only.
Yes, that is what I was telling you earlier. We are solving I thought there was some simpler method, very lengthy method, but now I realize this is the only method. We are using hypergeometric already, but we don't know it until we are formally introduced to it. Okay, in week 8 we
but there is the hypergeometric method, right?
Which hypergeometric?
The one that you showed right now, the one that.
Yeah. This is the hypergeometric method only, right?
Okay. I solved using this. This involves a lot of calculation. Okay.
Yeah, this involves calculation. That's why I had written lengthy method. So I was confused. Maybe there was some other method, but no, this is the method that is there for this question. Because as I mentioned already, we have already been dealing with this binomial, Bernoulli in week 9, 10, right? But then when we are formally introduced, we come to know, okay, we have already been discussing those. So let's come to one more question.
Sir, I approached this question. Can I tell, sir?
Yes. If you want to show, you can share.
Sir, can you show the question, sir, once?
You just take a screenshot of this question and you tell this. In the meanwhile, I will write down another question. Okay.
Okay, sir.
This is my next question, and I will.
Hello, sir.
Yes.
In the exam, is there any question coming from geometric distribution also?
I cannot say if it is coming or no. I don't know.
No, I'm asking because geometric distribution is not in the lectures, right?
Yes, but it is in the syllabus, as you have got a mail about this, right?
Okay.
You got sorry. Okay, let's take this question only.
Sir, this is the whole question.
No. I'm just writing it.
Okay.
Sir,
Yes.
I have a doubt. Like for the bonus marks, you all said that we have to do the practice assignments also, right? So like I am pending with some practice assignments. So can I complete them now, and will I be getting the bonus marks for that?
Okay. Sorry to interrupt, but I don't have much information about this practice. Or
Week 1 to 8, they have already taken the marks.
Yeah, after that.
Yeah.
From week 9 onwards, we can, right?
Preferably, you should do it. Yeah.
Okay. Okay.
So solve this question. Anyone solve this? Just the period.
Is it 2 by 13?
Sorry?
Is it 2 by 13?
I'll just write your answer. What you are saying? 2 by
13.
2 by 13. Okay, we'll see.
Sir, I'm getting 1.14.
1.14.
No, 0.14.
Okay, this 2 by 13.
No, I mean,
okay.
2 by 13 is 0.15.
Yeah, 2 by 13 is 0.15. Just let me calculate this.
Oh, okay.
So is that question number 2 or is that 2 cards are drawn successively?
No, this is 2 cards, not question number 2.
Zero 0.05.
Okay, let's see. Someone has got 0.05.
So we can use hypergeometric for variances.
See. So basically, such questions, they will be a range type, right?
I'm totally confused, sir. I'm not able to even start the.
Okay, I will discuss this question. Okay. I think I should start discussing this question because only half an hour is left and we are here to cover 9 to 12. Then we have to cover geometric as well. Okay. Now let me do this all. Now let my x denote the number of kings, right? Number of kings, right? My x is number of kings. Two cards. What values can my x state? It can either be
0, 1, 2.
Right? What will be my probability corresponding to 0? 48
C2 by 53.
Okay.
Divided by 52 C2.
Right, 52 C2. What will be my probability? Just let me take them a little farther so that it doesn't get jumbled. What will be my probability related to this one? It will be basically 4C1 into 48C1,
right?
Yes. From the 4 kings, I am choosing 1 king, and from the remaining 48 cards, I am choosing 1. It will be again 52C2. For this 2, it will be, what will be for this 2? 4C2,
48C2.
52C2. So this is my probability distribution, right? Probability x equals to xi, whatever that is. Now, if you solve this now that I've already solved this, this will be equal to 188 over 221. Okay, this will be over 32 over 221, and this will be equal to 1 over 221. Is this a valid PMF? Can anyone tell this? Is this a valid PMF?
Yes, sir.
Yes, sir. Yes, sir.
Okay, it's coming out to be equal to.
How we calculated this, sir?
I have already calculated. This is a calculation, right? We know the formulas for 40 NC2.
Yes, sir.
And in the exam, you'll also have access to calculator, so it will be a little helpful to you. And to save time, I've just done these calculations.
Okay. No, I thought there is some shortcut.
No. There is no. I just have to go through this. Or I had to go through this. So these are my values. Now, what is my expectation first? First, to calculate variance, I need this expectation of x, right? What is my expectation of x? This is 0 into 188 by 221, right? Plus 1 into 32 by 221 plus 2 into 1 over 221. Solving this, you will get this 32 plus 2, 34 over 221, right? This will reduce to 0. This is 32 over 221 plus 2 over 221. This will be 34 over 221. Okay. Now going for my x square. My x square will be something like this: 0, 1, and 4, right? Is this clear? This much is clear. So what will be my expectation of x square? This will be 0 into 188 over 221 plus 1 if I take from here only. 1 square is 32 by 221 plus 2 square into 1 over 221. This is basically 4. This is again 32. So it will be 36 over 221, right? This is my expectation of x square and this is expectation of x. Now, what is my variance?
36 by 221 minus
expectation
34 by 221 ka whole square.
Sir, not 36, right?
Yeah, 36.
So that is 36 by 221 the whole. Oh, okay. Okay.
Expectation of x square, right? Expectation of x is 34 over 221. Okay. Just be a little careful when you are approaching these expectation variance questions. Sometimes you might by mistake substitute one in place of the other. Okay. Just be a little careful in this point. So when you solve this, your answer should be in this range. I think it will be 0. Just let me check it. Which is over
1.36.
So it will be somewhere in 0.1 to 0.15. Okay, if you are in this range, it's fine. This is the range I'm considering.
Sir, we cannot use hypergeometric way.
What have I used here to calculate probabilities?
So for the formula for variance in hypergeometric is m by n into 1 minus m by n.
If you can go in that way, you just try it that way. If you get it, then it's fine. If not, just let me know what the discuss or discussion.
Sir, I tried it and it is coming to be 0.14. So
okay.
Fine.
Yeah.
0.1420. That is what.
Yes,
that is fine.
If you use the hypergeometric.
Okay. I've just given that in this range, right? That will be in this range.
Yeah.
So I think the time is already 9:30. Will be starting with week 10, 11. 10 is already done. 11, 12, and then
variance of x in variance of x x square is coming out to be 40 upon 221, not 36 upon 221.
36. Here you can see this. It's basically 2 square, right? 2
Sir,
square
how
is 4.
to identify when to use hypergeometric or binomial?
Sir, this one in e of x, this is last term is 2 upon 221, right? We have to just multiply 4 into it, so it will be 8, right?
Why do we have to multiply 4?
So because 2 square, right? 2 square into 2 upon.
Sir, she has not seen that PMF, sir. Just show her the table.
Yeah, PMF is this 0, 1, and 2 only. 0 square is 0, 1 square is 1, 2 square is 2. Okay.
P of x of 2 is 2 upon 221.
Right.
You write it
Yeah.
here.
Yeah.
So I am just multiplying 4 into it. So
No, you have to take square of this one. Okay. Take square of this one. 2 square. It will be 2 square is 4. I'm not multiplying. I'm just said this is 2 square equals to 4. This is what I've written. 2 square equals to 4. This is not multiply. Okay. Someone was saying when to use hypergeometric or when to use binomial. We will be covering that part now. Okay. That is the part that we will be covering now. Okay. From this point, Rajkishore will be taking the session.
Okay, good evening, everyone.
Good evening, sir.
So we'll be starting with week 11. Basically, if we start, I think week 11 consists of all the distributions, right? If I'm not wrong.
Yes, sir.
So basically, if you have to start with this, let's start from so basically, there are how many kind of different distributions you have learned from the discrete family?
Binomial,
I think
and
you
hypergeometric.
can start with Bernoulli. That is the basic distribution which you can think of, and then from there on you keep on just let's say if I have to start it, let's say you have only one trial, and in that trial, for example, you are tossing a coin, right? So in tossing a coin, it's just one normal one event only, or one trial you can say. In that, either you can get and let's say your head is a success, and let's say tail is the failure. So in this case, let's say it's a fair coin. So let's say it's 0.5 and this is also 0.5. So this kind of distributions, you can just model them to be as Bernoulli. Okay. So in this case, what happens? Bernoulli distributions, how basically what I will be trying to give you the idea is that given any kind of a question, how you can identify which distribution does that belong to. So let's say if you have given a question where something that you are given only one trial, and you have to find out kind of that either you will go means you can categorize it like either it's a success or a failure. Those kind of questions you can categorize them into Bernoulli cases. So like over here, we are saying that my output from that random variable can be either head or it can be tail, right? So if it's head or tail, then in those cases, what you can do is that you can find out the PMF for this. Let's say that if it's my X, then let's say it's H and tail, head and tail, or you can say if let's say success, I can code it as 1 and failure as 0, whatever you feel convenient. Let's say this is 1 and this is, let's say, 0. So for this case, it would be again 0.5 and tail also it is given 0.5. So this is the basic number one distribution that we are talking about, Bernoulli. Now, how that gets extended to binomial is that when in Bernoulli case, what I'm talking about is that I'm doing only one trial. So in case of binomial, how it would change? Anybody?
N trials.
Yeah, everything would be same. It just will make it n trials. Rest everything would be same. Over here, it is kind of saying that we are doing n Bernoulli. Okay, that would give me my binomial. So binomial can be equivalent to writing that is n Bernoulli cases. Okay, so everything what we would be deducing for Bernoulli. Where does this slide go? So anything what you will be deducing for Bernoulli cases, we'll just multiply them or extend it to binomial cases. Okay, it's better I get into that slide only. I think we have to go till week 10, right?
So quick question: are we going to continue after 10 also?
I'll try to cover up till what it is the geometric distribution. Okay.
And remaining, sir, next session.
Remaining in the sense?
No, we only have half an hour or less than half an hour. So I just asked, are we going to continue after 10 p.m. or are we going to like stop at 10 and then cover?
No. Anyhow, we'll try to cover it up today only. How far it may extend. It's there's nothing much to discuss. I think I'll just spend a little bit of more time to discuss what how you can identify the geometric cases. But in general, I'll go forward with just give us.
So the identification part will be great if you were able to tell us.
So that would be the more important thing. For example, let's say we are given in general, as I said about that. Let's say if a coin is tossed, Bernoulli, I think you would have had sufficient experience from, I think the week 11 graded was full of Bernoulli binomial cases, right? So I'll just give you a brief explanation. So let's say coin is tossed 5 times and I'm asking you find the probability of exactly 2 heads. Okay. exactly 2 heads, and let's say and the other case can be at least 4 heads. So the first thing to notice about over here is that because we are given, let's say this is a identifying technique, you can say that the first keyword that we can notice is that 5 times. So for always for binomial cases, the most important thing would be there will be fixed number of trials. Okay. And over here you can see the trials. What is the fixed number of trials? It is 5. Correct. So that is the first thing to notice. Now, as I was saying that let's say if you try to solve for this case, can anybody tell me what would be the expression for exactly 2 heads?
NC2 into 1 by 2 power
5C2 1
Okay,
by 2 raised to
1 by
power
2 power
5.
5C2 then 1 by
1 raised to power 2 into 1 by 2 into 2 raised to power 3.
Correct. So if I have to do 2 and 3, let's say if I'm saying probability head is, let's say 1 by sorry.
No, I didn't get it. How is it last 1 by 2 power 3?
I'm saying, okay, I'll just give me new expressions from this part. Okay, probability of tail is 3 by 4. Now can you tell anyone?
P 5C2 1 by 4 power
1 by 4 power 2
by 4 power
and 3 by 4 power 3.
Yeah, correct. So now whoever was asking the doubt, so I'll try to divide this expression into smaller chunks. Okay, so what does this 5C2 say? The 5C2 part says that when we are talking about exactly 2 heads, let us consider that head is my success and tail is my failure. Okay, this is the first assumption we'll go about with let's say this is the success part and this is the failure part. So when I'm saying 5C2, it says that I'm attempting 5 times or I'm doing 5 trials, and out of those 5 trials, exactly 2 heads. When you can see that it is like out of those 5 trials, I'm succeeding 2 times. Okay. Now this 5 out of these 5 trials, let's say it is N1, N2, N3. It is like the combination. We are going to that combination part again. If these 5 are my trials, then out of these 5 trials, I'm choosing any 2 trials to be my success. So that can be done in 5C2 ways, right?
Yes, sir.
Once I'm done with that, once I choose out of, let's say I'm choosing N2 and N5 to be my success trials. Okay. So just a second. So if I'm choosing my second and let's say N2 and N5 to be my success trials, so then I have to choose. I've chosen that N2 and N5 from 5C2. Once I'm done that, what is the probability of individual success? That is what I was talking about in the Bernoulli case, right? That if though I'm doing it for how I am getting binomial, it is just the extension of n times Bernoulli, or over here I can say 5 times Bernoulli. So if I have to say for one particular trial, what would be the success? What would be the probability of success? It is 1 by 4, right?
Yeah.
Yes.
So if it is 1 by 4, then I'm getting success how many times? It is 2 times, right? So I can write it 1 by 4 to the power 2. Now, if out
same with 3 by 4 power 3. Okay, sir, got it. Yeah.
So if I have got from out of 5 2 times success, then 3
Sir,
times.
Sir, how do we get the 1 by 4?
1 by 4 is the individual success. Okay, individual success of a trial. In one trial, what is the success? Probability of success. That is 1 by 4 given to us in the question, right? It's an arbitrary. How did we get 1 by 4? We are not get. I just gave you an arbitrary number.
Okay.
So if it is 1 by 4 is my success rate in one trial, then if I have got 2 success, means in my out of my 5 trials, if I have got 2 times success, so I can write it 1 by 4 to the power 2, right? And if I have got out of 5 2 times success, then obviously I would have got 3 times failure, and the failure probability was 3 by 4 given to you. So that would be 3 by 4 to the power 3. Is this okay?
Yes, sir. Yes.
Yes, sir. Yes, sir. 3 by 4 power 3, right?
3 by 4 to the power 3.
Okay.
Okay. Now the question comes that how is this different from hypergeometric cases? Anyone would able to say anything about this? Like how you can distinguish?
There will be without replacement. Without replacement.
one by one.
Yeah.
So that is a replacement allowed and a
So
replacement.
without replacement is hypergeometric case.
With replacement and without replacement.
Exactly. I think maximum of your
So
saying
here the trials are independent, but for hypergeometric cases, the trials are not independent.
correct. All of you are correct only. So I'll just summarize whatever points you have all said. So for example, I'm just going to that. Okay, I think we have already, yeah. So for example, what happens in these cases, if you see in binomial case, the one more important thing which is to be taken care of is that IID term. Okay, what happens in this case, as I was talking about that I can write binomial equivalent to what? N Bernoulli cases, right? Now, when I'm saying N Bernoulli cases, this part, if you keep, notice that it is independent identical distribution. So first thing to like in the last question, what you are doing, how many trials we took? It was 5 trials, right? So each trial had, if you have noticed, it was the probability of for each trial success was fixed. That was 1/4. And for probability of tail or the failure, it was always 3/4, right? So every trial, my probability distribution was fixed. That is why it is said identical. It is not changing. And independent, you can say that each trial is independent of the other trial. They are not influencing the other trial. If these all cases are satisfied, then we'll say we can apply the binomial thing. Okay. So for binomial, what are the points you have to keep in mind? One is fixed number of trials, right? The first thing is fixed number of trials, and the second thing is it has to follow the IID case. And if you see the last question, what we are doing, we had 5 trials. So already my number of trials is fixed. Once I have the number of trials to be fixed, then I will talk about the identical or the independent cases. That is, as I was talking about, that head was always fixed to be 1/4. So it is all obviously identical, and tail was fixed to be 3/4. So in these cases, it will always be, you can blindly put or implement the binomial cases. Now in hypergeometric case, what happens? If you see that.
Hello.
Yes.
So
Yeah.
I have a doubt. So I have doubt in square and cube thing in your combination that you showed.
Square. Okay, tell. So this is the base formula. Okay, what we were
No,
using.
sir. Sir, the example you were showing now, that combination into 1/2 square
I'm talking.
into
See,
3 yeah.
You had 5 trials, right?
Yeah.
And the question asked you was exactly 2 heads. Okay. You had probability of head to be 1/4, probability of tail to be 3/4. Okay.
Yes, sir.
Now, when I'm saying exactly 2 heads, I had 5 trials. So it's like 5 times I'm tossing a coin. So or the 5 tosses to be each individual trials happening 5 times. Okay. Now in each individual trial, the probability of getting a head is 1/4 and the probability of getting a tail is 3/4. So now if I'm tossing it 5 times and I want to find out exactly 2 heads. So out of those 5 attempts, I can have any 2 attempts to be my head, right? That I will do in 5C2 ways. That out of those 5 attempts, any 2 attempts will be my head. Is this clear?
Yes, sir. Okay, sir.
Now, once that happens, now each head, if I'm telling to be the success, that is 1/4, then it would happen 2 times. So it would be 1/4 to the power 2.
Yes.
Once that happens, is this clear?
Yes, sir. Thank you.
Okay. If you have to just correlate with this PMF formula, it is this part. This N is your 5. I is the number of success, that is 2 over here. P is the probability of success again. So 1/4 to the power I was 2, and 1 minus P is the failure rate. Okay. That would be 1 minus 1/4. According to our question, that would be 3/4. And N minus I would be number of trials minus number of success trials. So it was N minus 2. That would be 3. Okay.
Yes, sir.
So now if we have to go for, I think in this case, so as I was talking about that, how it is different from the hypergeometric case. In hypergeometric case, what happens? is that the first thing to keep in mind is that you will get a brief idea from when you read the question is that there will be two kind of categories and you are trying to divide them into two categories. Let's say, for example, there is a population of 50 students. And out of those 50 students, let's say 20 are boys and let's say 30 are girls. Okay. So when you get this kind of questions, you have to find out that, okay, maybe the question is asking me to implement geometric cases. Now, again, how is it different? Again, if I have to say that the same question, if it is 50 students and there are given 20 boys and 30 girls, you can again easily say to me that, okay, sir, I'll be using, let's say, if I'm asking you exactly, tell me, let's say 2 boys. Okay. Out of these 50 students, I want 2 boys. So is there a way where you can find, like I'm saying you, that I will pick 10 students randomly, and I will again replace them. Okay, means it's like there are 50 students who are sitting inside the class and I'm standing outside. I'll go peep into the class. I'll call randomly any student and they will come out. They will write their name in a sheet and again go back to the class. And this way I will repeat it 10 times. Okay. So, and I'm asking you that what is the probability that a student comes out, writes their name and gets back to the class. And at the end, if I check my sheet, there will be exactly 2 boys. So can anybody tell me how to do that?
Binomial distribution, we can probability of success by 2 by 20.
Okay. If first thing is, if you're saying it's a binomial distribution, tell me what is the number of n?
N is 10.
Correct. N is 10. Anybody any doubt in this part? How to get how n is 10?
No, sir.
Okay. Next, tell me.
Repeat the last part of your question.
Okay, I'll repeat the question once more. There is a class of, let's say you people are only there. There are 50 students inside the class. I'm outside the class and I want 10 volunteers for let's say event. Okay. And I randomly get inside the class. I call arbitrarily that, okay, anyone who is interested, come outside and write your name in a paper and get back inside the class. Now it is like that because I'm not monitoring, anybody can come outside and write his or her name twice, thrice, any number of times. Okay. So tell me that after 10 iterations, what is the probability that if I check my sheet, there will be exactly 2 boys' name in that? Means, let's say I was asking them to write their name as well as gender. Okay. So what is the probability that in that sheet, there will be exactly 2 boys?
It will be 10C2 into
success 2
1 by 20.
Hold on. First thing is I will segregate my getting a boy to be as my success and getting a girl to be as my failure. Correct?
Yes.
So what is the probability of getting a boy?
1 by 20.
20 by 50, right?
Yes, 20 by 50.
Probability of girl would be 30 by 50.
50 by 50.
Is this clear to all? Now tell me how to put it into expression. That would be, let's say, probability of x equals to 2. What it would be?
10C2. Sir, how boys are 20 by 50?
5 to the power 2.
Okay. So who was asking the doubt?
20.
See, as I said, the question is that every time I get into the class and start calling a boys, what is the population of boys inside the class?
20.
Sir.
20.
There were 20 boys inside the class. Anytime I go and call out, so means I just call for a boy from the, call a student out of the class. Always I'll be having 20 boys and 30 girls, right?
Yes.
The probability of getting a boy will always be out of the 50 students, only 20 students can come outside.
Yes, correct, sir.
So it would be 2 by 5. That is where I'm saying that this thing is that it is independent and identical, because every time one student writes the name, he again gets back to the class. So my population of boys is not changing, right? So my probability for every event or every trial would always remain constant. That is, my boys probability will always remain constant and my girls probability will always remain constant for every trial. Or over here, my every trial is what? I will get inside the class and I will call that okay, next volunteer, get outside and write your name and get back in again, right? That is my every trial. Now in every trial, because after writing the name, the boy or the girl is getting back inside the class and sitting again. So my this ratio is not changing. That is always, it is remaining constant. That would be 20 and 30, right?
Yes.
So these are the things to keep in mind when you are finding out for the binomial case. That always for independent trial, my probability is not changing. It would be the same only. Okay.
Yes.
So that way, so okay, so we'll finish it up. That so it would be 10 C2. That out of my 10 times calling a student and making them to write their names, it can be any two calling where I will be getting 2 boys, right? So it can be 10 C2, and then the probability of boy, how much it would be?
20 by 50.
2 by 5.
Yeah, sorry, 2 by 5 raised to the power 2.
Okay, just give me a second. Where did it happen? Okay, tell me.
2 to the power, sorry, 2 by 5, the whole power 2.
2 into 3 by 5.
3 by 5
The whole power 8.
raised to 8.
Okay, 10 to the, 10 C2, then it is?
2 by 5 raised to 2.
Yeah,
okay.
Into 3 by 5 raised to 8.
3 by 5 raised to 8, correct. Okay. So till this it's clear?
Yes, sir.
Yes.
Okay. So I'll just get back to that part. Hold on just one second. Okay, where I just lost.
Zoom out, sir.
I think it's not got into some. Okay.
Sir, try pressing EC.
Yeah. So that was the first part. Okay, then I think do I need to explain this expectation part and all? What is the formula for this NP or NP? These things these are very direct, right? The variance and expectation. Okay.
Yes, sir.
So next part, what I was talking about, I'll get back to just that geometric part where it was. So that so what happens is that as I was saying, I'll just modify the same question for you all. That again, that there are same students, 50 number of students. And now what happens? The same, I'll call for a student. I'll make them write their name and I will ask them to leave the class. Okay. So there are again 20 boys and 30 girls, right? Now everyone writes, any one of them arbitrarily comes out. I will be writing 10 students' name. So now what is the change from the last question? That anyone who writes the name, he is not getting back into the class again for the next call. They're leaving the class and going for their other work. Okay.
Yes,
so now tell me what would be the probability of x equals to exactly 2? Anyone?
Your 20 C2 into 30 C8 divided by 50 C10.
Okay, 20 C2 then multiplied by
30 C8.
30 C8 divided by
50 C10.
50 C10. Okay. Anyone with any other answer or all are agreeing with this? Okay. So now the first thing, why it is not done now in the binomial case, with respect to binomial distribution, the important thing is now every time I get into the class and call for the next student, it is what? It is my another trial, right? So I'll be taking 10 trials. Now, if you see for the first call, let's say I'll just try to model it. Then let's say this is my first 5 trials. Okay, let's do that. So in my, let's say in the first trial, I got a girl who wrote his name. Now for the second trial, how many boys would be there inside the class? It would be still 20 boys, right? But the girls would have decreased. That would become 29 girls, right? So my probability for the second time when I get into the class and call somebody, my probability of boys is still 2 by 5 or 2 or 20 by 50. And my probability of girls has ultimately changed. That becomes 29 by 30. So this is the difference from the earlier case. In this case, for every event or every trial, my probabilities are not remaining constant. That is, this is not getting to me a IID case. Okay. So in exam center,
Why is it by 30? 29 by 30?
Sorry, it's not 30, it's 50. Okay.
So like number of students will, total number will get reduced, right?
49, sir.
It will become 49, right?
Yes, sorry, my bad.
When it is without replacement. What about probability of boys? That also will become 20 by 49.
Right. It would be also 29 by 49. Okay. Sorry, 20 by 49. Is this clear?
Yes, sir.
Yes, sir.
Okay. So basically you got the idea, right? So next time if it's boy, for the third trial, my probability of boys would change to 19 by 48 and probability of girls would change into 29 by 48. Okay. So this is the ultimate difference between binomial and in case of geometric hypergeometric case. Why? Because in each trial, my probability values are not remaining constant, or that is my IID case is not maintained. Okay. Now, how to solve? So this is the first thing, how to identify or differentiate where I will be applying binomial and where I will be applying hypergeometric. Now, how to decipher this part or this PMF probability mass function, or finding out the probability for any particular random variable which is maintaining hypergeometric distribution. So how are you getting this 20C2? Anyone would like to explain? Am I audible, guys?
Yes, sir. Success, sir. Interested case. Sir, from 20 was written randomly select any two.
Sorry, whoever.
Is 2 boys out of 20 boys?
Correct. So first thing is to note for us, again, the same case like, just a second. Anyone, whoever is talking, for the like correlating with the last problem over there, what was given to us, probability of x equals to 2, that was exactly 2 boys, right? So for us, the matter of concern was the boys. So over here also, you have to see what we have been asked. So that would be my concern part. So over here, if I had exactly 2 boys again, so M says me in my equation, if I have to say, M says me whatever is asked to us, what is the count for that, or number of count, or you say, or you can say the population of that part. Okay. So over here, how many boys we had? It was 20 boys, right? So the first part says that whatever we are asked, that is x equals to 2 as for the number of count of boys. So that would be 20C2. Now next part is, if we have been asked for 20 out of boys it is 2, then obviously the rest would have to be girls, right? And the population of girls was how much? It was 30. And if 2 boys out of 10 are 2 boys, then obviously the other part would be 30C8. And in the denominator, it would be in general 50. That is my total number of populations. And from that, how many I have to choose ultimately? That would be 50C10. In general, to correlate with the last question, what we were doing, ultimately we had 20 boys and I have to choose 2 boys out of them and 30 girls. And out of the, if I've chosen out of 10, 2 boys, then it would be 8. And how many people I will be asking to write their names? 10 people. And out of how many students? 50 students. So that would give me probability of x equals to 2. Is this clear to all?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So I think that would suffice for means differentiating from binomial cases and hypergeometric cases. Just see if I'm missing out on something. Okay. Expected, again the same way. You can just directly find out the expected values also, right?
Yes, sir.
Then next cases where you have to find out the what are the distributions you are left with. One is done with this. Okay.
And exponential.
Okay. So we'll go for the first. Let's finish out the discrete cases. Okay. So next kind of distribution is the Poisson distribution. So how can you know that when you are talking about that distribution is Poisson or not? When you are talking about Poisson distributions, it is like, for example, the points or the keywords to find out from the question would be that, let's say it is given in a frequent interval of time, and we will be assuming, I think there was a very good word over, if you see that in a fixed interval of time, we are trying to find out some observations we are taking. Okay, let's say you can say it this way. For example, we'll try to find out let's say any student, and we are trying to plot for his whole day, because tomorrow, let's say this Sunday, you have your exam. So your parents try to find out that I'll try to find a means plot your activities for the whole day. Okay. And how they will check it? Per hour. Okay. In per hour, they will get to your room, study room, and they will see that how what is the amount of time or how many what is the frequency of time you are getting into your mobile, or maybe you are getting into social media or something. So let's say they try to note it initially from morning 6 a.m. to let's say 12 a.m. Okay, not 12 a.m. Not to confuse. Let's say take 10 a.m. Okay, before your breakfast, they are trying to check for per hour time. So let's say from 6 a.m. to 7 a.m. you have peeped into your mobile, or you got into a mobile and you started browsing, let's say 7 times. Okay. From again, let's say 7 a.m. to 8 a.m. again it is let's say 12 times. From again 8 a.m. to 9 a.m. you have done it 3 times. 9 a.m. to 10 a.m. they got really angry and you decreased your intervening into the mobile your mobile phone, and it is 1 time. Okay, so if you get this kind of pattern of questions, those you have to follow. First thing is this is discrete case. Okay, every time you are getting some discrete values, so this kind of cases would fall under Poisson distribution. So over here, what was my interval of time? It was 1 hour, right? In every 1 hour you are finding out some observations. And what is the observation? These are the observations: 7 times, 12 times, 3 times, 1 times. These were my observations. Okay, if you just have to take it from let's say one example out of this, I'll just give a very quick example. This is also very straightforward case in general. So just give me a second. So let's say the question can be like, let's say you have a computer and it crashes once every 4 months. Okay. Or if somebody doesn't crashes in the sense it you find out some defect in your computer once every 4 months. Okay, so what is the probability that it will not crash in a period of 4 months? It will not crash in a period of 4 months. Okay,
1 minus the problem.
Not crash in
That it will crash in
4
4
months. Okay, so how can you find this?
1 minus the probability of it crashes in 4 months.
So first thing is what would be my random variable? That how many times
it
crashes. So if I have to find out that it doesn't crash in the next 4 months, so what should be my random variable value?
0, sir.
Correct. It should be 0, right? Because if my time period is 4 months, then any number of times let it be the computer is crashing. But if it is not crashing, then I can say directly that my random variable is taking the value 0, isn't it?
Yes, sir. And lambda will be 4.
Sorry?
Lambda will be 1.
Lambda will be 1 because what is the frequency in every 4 months my computer is crashing? It is once, right?
Yes.
So that would be my lambda value. Anyone who didn't get this part, like how did we get lambda value as 1 and x value as 0?
Sir, please come again.
Okay. So if you just go through the question, what does it say? That I have a computer and I see that every 4 months it crashes once. So each word over here has to be kept in mind. First thing is every 4 months. So what should be my period of time? 4 months. Now, how many times does it crash? It is once. So these are the two things we have to keep in mind when we are talking about Poisson distribution. That what is my time interval or frequency of time? And second thing, in that frequency of time, what is my average observation? Over here, my observation is that my computer is getting disrupted or it is crashing once. And that value is to be my lambda or the average value. So it is coming out to be lambda equals to 1. Now time period or the frequency comes out to be in every 4 months. Now why we are saying x equals to 0? My x value says that how many times my computer is crashing in 4 months. Okay. Now if I am asking you the probability of not crashing in 4 months, so obviously in the next 4 months, we are not seeing our computer to be getting crashed. So I can say that my X value to be 0, right? Now, if you go to the PMF value, it is e to the power minus lambda multiplied by lambda to the power x divided by x factorial. Okay. This is the PMF value to be found, the PMF value for any Poisson distribution. So over here, what would be my E value? Sorry, e to the power minus lambda. So lambda value would be how much? It would be 1, right? Because averagely in every 4 months, I was seeing my computer to be crashed once. Correct? Now it would become lambda to the power, what would be my X value? 0. Because we are finding out for the case where my computer is not crashing at all in the next 4 months. So it would become 1 by 0 and this would become 0 factorial. Is this clear to all?
Yes, sir.
Sir, actually, when I'm coming up with these questions, I'm unable to get like which is lambda and which is x. Like, how do we differentiate between these two values when a given question is there?
Okay. So if you see in this question, x is the value that is being asked for you, that in the next period of time, this is the observation we are looking for. So what is the probability of that? Okay. Like over here, we are looking for the observations where what is the probability that in the next period of time we'll be not getting x equals to 0. If I have to just let's say we'll take one lamb. Yeah.
So what if like we have a period of 8 months, then lambda will be 2 or 8?
Why would your lambda value to be 2? Lambda value depends on the number of observations. Okay.
Like for 4 months, it is lambda is equals to 1.
Okay. This is a good point to be kept in mind. Let's say, okay, first I'll finish this part. Whoever was asking about this lambda and differentiation between lambda and x, just give me a minute. Okay, I'll get back to your question. Others who got this part, just to add on.
Lambda is actually mean.
Correct.
Oh, yeah.
I'll show that part also once. Just those who got this part of the solution, what I think Sanjoli was asking, we can change it this way. Then let's say it is given, the question is similar, the same question, but now if I change my question, the last part of the question, that what is the probability of not crashing in 8 months? Okay, if I change the question now, how can you do that? What would be the lambda value?
So lambda will be 2.
Correct. So this is the part to be kept in mind, that because your distribution in general is given for 4 months, and now the observation value I'm asking you for twice of that interval. So my lambda value or the observation value will obviously be also changing, because if this is kind of common sense, right? That if I say you that the average height of a classroom is, let's say, 5 feet, then if I double it for 2 classrooms, then obviously it would change, right? It would become 5 into 2, right? So if I'm saying that in 4 months, if I'm seeing my computer to be getting defective once, then in 8 months it would be obviously 2 times. So that would become my lambda value. Okay. Rest everything would be same.
And so what if in the same question they were asked, it does not crash, it crashes in 8 months then?
So if they're asking you, okay, if I change the question again, then let's say probability of crashing twice in 2 months. Then how would the question change? Means how will your formula change? Anyone?
Lambda is equal to.
Sir, lambda will be 4.
And
Lambda will become 0.5, sir.
So one by one.
Lambda is equal to 2 and x equal to 2.
Lambda equals to 2 and x equals to.
And question is same, sir, 4 months.
Correct. It is the same question, that the observation is the computer crashes once in every 4 months. What is the probability that my computer would be crashing twice in, this is 8 months. In 8 months. So how would your question, your approach change?
X will be 2, lambda will be 2.
Okay. Any more
That will be
answer?
2 and
Lambda will be
will
1
2.
only, right?
Why lambda would be 1?
X equal to 1, lambda equal to 1.
Okay,
So
whoever
what
is
is
saying,
the correlation between them? Actually, we are not getting that. The lambda x, what is the relation between them? Because we are changing the value of the months and lambda is also changing. So I'm not getting that in personal.
okay, I'll just get back to that question. Just I'll take more one question what ma'am has said. Okay, let's say, what does this question say? Suppose the number of accidents per week in a factory can be modeled by the Poisson distribution with a mean of 0.5. Okay, now in this question, how would you find out the lambda value and the x value? Now, if you
Lambda
see
is 0.5.
this part of the question with a mean of 0.5. Now, how did we get this mean of 0.5? Let's say first thing is whoever was asking this question, the lambda tells you the average number of observations. Okay, is this clear?
Okay. Yes, sir.
And
Yes,
x
sir.
tells you number of observation. Okay, now what we are talking about, it is saying you that x be the number of accidents per week in the factory. So first thing is, let's say they have collected data for 1 year. Okay, so in the first week they collected data and they found out that how many accidents has happened. It is talking about, yeah, let's say 5 accidents happened. Okay, for the second week there were 10 accidents. For the third week there were again 2 accidents. Similarly, it will continue till let's say if you're talking about 1 year, in 1 year how many weeks would be there? Let's say for 1 month you are getting 4 weeks, right?
52 weeks.
52. Yeah. So this way you will be having 52 observations and there will be different values for that 5 accidents, 10 accidents, 2 accidents. Now, if you do an average of it, you will get an average number of accidents in the whole year. Right?
Yeah, right.
That would be my lambda value. Let's say arbitrarily, I'm not calculating it. Arbitrarily, it comes out to be 3 accidents. Okay. So now how I can formulate my question, that I have taken a data set and I have observed that the number of accidents happening per week is 3. Where the number of accidents happening per week is 3 accidents. Okay. So what does this say? That on an average, there will be 3 accidents per week, which I can reframe it, that the mean number of accidents can be again 3 or something this way. Okay. So whatever we are saying, whenever you get this kind of thing, that is either it will be mean given to you or average number of accidents given to you, or in the last question, as I was talking about, that once in a week. So basically when I'm saying that my computer is getting crashed once in a week, basically it is not saying that in the next week it has happened once. It is saying in general, if I would have noticed my behavior for, let's say again 2 years or 3 years, then this is the average number of times my computer is getting crashed or getting maybe getting faulty, average number of times in a week. Okay, that is that average number comes out to be 1. Is this clear?
So, like when you said
Yes,
like for 4 months, like every once a month the computer crashes. So when someone asks that what about the 8 months, you said it will be 2. The value of lambda would be 2. So how did we come up with that 2?
I'm getting to that part. So first thing is, let us get only lambda for 4 months, okay, or the period of time. Then we'll get to the other parts. So for the period of time, is this clear that how that in that part we are getting once, or over here how we are getting 2.5?
Yes.
Or if I just modify the same question, that number of times my computer crashes is thrice. Okay, that is if I say you that in a week I have observed, my observation follows a Poisson distribution, and in a week I'm seeing that my computer is crashing 3 times. Okay, so how would you interpret this in a week? The moment you see this part, what should be your interpretation of this question? Anyone?
It's a Poisson distribution. It's a Poisson distribution with lambda 3 per week.
Lambda is equal to 3.
Lambda is 3, it's okay. But
Mu of
in a
5, 0.5.
physical sense, what you can say is that for a long period of time you have noted, means you have noted the data and you are seeing that on an average in a week, my computer is getting crashed 3 times. Okay, is this which mark each word of my sentence? Okay, that you have noted the data for a long period of time and you have found out that every week on an average my computer is getting faulty or getting disturbed or getting crashed 3 times. Is this clear? This is what you can interpret from this word, given that it's a Poisson distribution. Is this clear?
Yes.
Yes.
Okay. Now when I ask, yes. Can you
one doubt on this accident story. So you know, the question is less than 2 accidents, and in the answer need to find, you know, x less than or equal to 2. So ideally it should be just 0 and 1 case.
Find the probability that in a particular week there will be less than 2 accidents. Okay, yeah, it should be basically 0 and 1 case.
Yeah.
This I think just it would be, means by mistakenly ma'am would have taken this.
If it is in that case,
sorry,
then how will we make it? Like if it is in the 0, 1 case, how will we change this?
It would be just normally.
In the answer, I think that's 0.0758. That should not be added.
Yeah, this part won't be there.
Yeah. Sigma 0 to 1 it will be. I is equal to 0 to 1.
Correct. This would be 0 to 1. Is this okay?
Why sir? It is equal to 2 also, no?
No, it's given the particular week there will be less than 2 accidents.
Okay.
It's not given less than or equal to 2 accidents. Okay. So these are just minute mistake. Maybe ma'am is overlooked it. Okay. So basically, so now once we got the lambda value, that is for our average number of observations, average number of times that happens. Okay. Now whoever was asking that why did we do it lambda equals to 2 for 8 months, right? So now because that was my one distribution that we were talking about, whatever may be the distribution or the PMF. In that, what was my frequency of month? It was 4 months, right?
Yes.
But now when I'm asking you for a new means what? Now I'm asking you the probability that is not for 4 months. I'm asking you for how many months?
8 months.
8 months. So basically, I'm not following the earlier distribution. I am making a new distribution and I'm deriving it from the earlier distribution. Now, as I said you, for Poisson distributions, I have to always consider the frequency of the time, all right, or the frequency of the interval. Correct? So for my new distribution, what would be my frequency of time? That would be 8 months and not 4 months. Is this clear?
Yeah, right. Yes, sir.
Now, if in a general sense, if on an average, if I would have asked you that in 4 months, how many times your computer crashed and you said it's 2, then how many times would that happen in 8 months?
Okay, sir. Yeah, I got it. So like it's like 1 crash for 4 months. So X crashes for 8 months. So that would be 8 by 4 equal to 2.
Can you just repeat it once more? But it is.
I'm saying that 1 crash per in four months, right?
One crash in 4 months. Okay.
Yeah, so 1 crash equal to 4 months. X crashes equal to 8 months. We can just cross multiply it. So we'll get X is equal to 8 by 4 and that would be X is equal to 2.
Correct.
Okay. Okay, I got it. So yeah.
Because this 1 crash is not the exact value. This is the average value, right?
Right, sir. Got it.
So it's like in the same example, lambda is calculated for 4 months. Lambda is given for 4 months and we are calculating the probability for 8 months. Similarly, can we, is there the possibility that we can calculate the probability for 2 months? Can we reduce it?
Yeah, correct. You can do it. You can reduce it also. For example, again, just I identify it this way, that on an average, my observation was that for 4 months, my computer was getting crashed 2 times on an average. Okay. Now I am asking you for the probability of not crashing my computer in 2 months. So I am not actually referring to my previous distribution. I'm trying to frame a new distribution. And in this new distribution, what would be my period of time? It would be 2 months, right?
Okay.
Now my lambda value will change because I'm finding a new distribution. My lambda value will also change. So on an average, if I was saying that my computer was crashing 2 times in 4 months, then in 2 months, how many times it should crash?
It should be 1.
1 by
Sorry,
2. 1 by
correct.
2. Hmm.
1 by 2, sorry, or it should be 2 by 2, right? So it should be 1, right?
Yeah.
Sir,
yeah.
what-
Yes.
Okay, I think the numbers we got disturbed. Okay, I'll tell you like the numbers what I was talking about. Okay, so I'm saying that in 4 months, my computer is crashing 2 times on an average. Okay, on average.
So can we change the numbers? Like
in
we
2
already
months,
got
1.
the same numbers and we got confused.
Okay, in 4 months, 3 times. Is this okay now?
Okay, yeah, yeah.
So now in 2 months, how many times should it change?
3 by 2.
Sorry,
Yeah. 3 by 2.
3 by 2.
Correct. It should be 3 by 2 or 1.5 times. So now is this clear how we are deriving the lambda for our according to our question?
Yes, sir.
Okay. Now once we are done, so this is my new distribution. Okay, and in this my frequency.
Here, just a minute. So here I have a doubt. So since this is a discrete distribution, sir, can we take the value 1.5? Like
This is
there can't be a 1.5 crashes, right?
That is value of lambda. Average
again.
value.
Okay.
Exactly.
For average, we can take it.
Yeah, this is not. Don't confuse it. When I say it that in a class the average height is 5.2 centimeter, it doesn't mean that individual anybody's height is 5.2, right? Sorry, centimeter. I'm saying 5.2 feet. It doesn't mean that individually anybody's height is 5.2. It's that on an average, the height is 5.2. Correct. So on an average, the number of crashes is 1.5 in the time period of 2 months. Okay. Now the question that we are talking about, that in that period of 2 months, what is the probability that my computer won't get defect or won't crash? So over there, my X value would become 0. So when you are trying to find out the random variable, so that in those cases, my X equals to 0 would say that in the period of 2 months, my computer won't crash. If I'm saying X equals to 1, I'm saying that in the period of 2 months, my computer is crashing once. If I say X equals to 2, I'm saying that in the period of 2 months, my computer is crashing 2 times. If X equals to 3, I'm saying that my probability of my computer crashing 3 times in the period of 2 months. Okay, this is how you will interpret it. But still, my average is still the same. That my data says that my data says that on an average in 2 months of time, in a period of 2 months, my computer can crash 1.5 times, right? Is it clear or you are getting confused?
Yes, sir. Yeah, I got it.
Clear.
Yeah.
Okay, so now it's clear. So for this again, we'll be doing the same thing, e to the power minus lambda, lambda to the power n or x, whatever it is, by x factorial. And similarly, you can find out all the possible cases. Okay.
Yes, sir.
Okay. So this, I think, okay, then we are starting with a continuous case. In continuous case, whatever was happening.
Just one doubt. For post distribution, what is the variance? Is it lambda only or lambda square? I saw somewhere when you are, browsing.
Lambda square? No. I think it is expected
Lambda.
is always be lambda only.
No, expected is lambda. I'm asking about the variance.
Variance is also lambda.
lambda.
Yeah, in
Okay.
one of the slide, clear. Okay.
Okay.
Great. Yeah.
Maybe one more point I can add you that expected value in general intuitively, what does that mean? It means the average value, right?
Yes, sir.
Yes, sir.
And that
here
is also
it
equals
is
to lambda. So you that also can give you an interpretation that actually lambda is nothing but the expected value, sorry, the average value only over the distribution, right? In general, when we are talking about the distribution, let's say 1 and this say 2, and let's say it is 3, and let's say this is for 4 and it is for 5. When I was talking about expected value, in general, what I was talking that what would be the average value? What would be the average value that my random variable can take, right? That was the interpretation of expected value, correct?
Yes.
So if you see it this way also, that over the distribution, whatever my x can take, means through Poisson distribution, lambda would be the average value of that. Is this clear?
Yes, sir.
On the same note, sir, for this variance, even I also asked Farad sir that n square minus 1 by 12, but in the uniform distribution, we got it as b minus a the whole square by 12, right?
Correct.
Then how did we get n square minus 1 by 12?
That is different. See, this is
Yeah,
continuous.
n square minus
This is
1 is,
continuous.
yeah, that's for
That is
discrete.
Yeah. Yeah, that is discrete and this is
Yeah.
continuous.
One is
Different.
Okay.
Okay. Now, from the discrete case, how continuous is different? I'll just give you a short, very quick idea. That in discrete case, if I was supposed to say that x equals to 1, 2, 3, 4, 5. Okay. So whenever I was saying that, let's say my probability value was something to be, this is 0.2. Let's say this is, I'm something saying 0.3. So if I have to say probability of x equals to 1, you can directly say it's 0.2, right? Now, whenever we are talking about continuous case, let's say it is given that it's starting from again 1 and it's ending at 5. Because it is continuous, so I won't have discrete values. It will be the whole value, means altogether value. And let's say this is some arbitrary area. I don't know what is this area. It's some arbitrary area. Okay. So over here, can you say me what would be the, let's say this part, if this point is, let's say 2. So this is a continuous case. What would be the probability of x equals to 2? Anyone?
0.
Okay. Anyone, any other values other than 0?
No, sir, it is 0.
So this is the difference between discrete case and continuous case. That in discrete case, we can exactly find out for any particular value the probability. In continuous case, we can't do that. We can always find out for a short strip. I think you all have done integration, right, in Maths 1?
Yes, sir.
Okay. So basically for a short strip, we can always find out my probability values. So basically what does this, then you can ask me that what does this give? In this case, it was probability mass function. In this case, it is probability density function. So what is density? That
Area.
this whole part, if I'm dividing into my whole probability, means let's say whatever the probability value I'm getting for a particular unit, what would be my value? Let's say if I have to do it for a uniform case, I will I'll be giving you an idea from there. It would be easier. Where does that 1 by b minus a part comes? Somewhere it should be. Okay, yeah, this part we are talking about. Yeah. So if this part is your A and this part is your B. So in this, so this distribution says that, what does this distribution say? Uniform distribution, that inside my x can take values within A and B, right? Now, if I have to take all the probability values, whatever are there, and sum them up. So what would be my ultimately what would be my summation value?
1.
It would be 1, right? So now if I have to say that for whatever this infinitely small points you take, this let's say this is a small strip, another small strip. If I'm finding out and adding them up, it would sum up to be 1. Now, if I have to say you that what would be per unit value, how much it would be? It would be just, if you have to find out this length, that if this length is b minus a, right? So in the per unit length, what it would be? It would be just 1 by b minus a, right?
1. Yes.
Is this clear to all?
Yes, sir.
Yes, sir. Yes, sir.
If I'm saying that for the whole summation, it is 1, then for per unit, it would be 1 by b minus a, right? So that is what my probability density is giving me. That if I have my probability for a whole area, then for a small area, what would be my probability value? So that would be what? Exactly, it would be whatever would be the total area, that is, let's say x, and sorry, what would be the total value for this x area? Let's say it was something a, and my area was something total, the value was to be a, and if my area was to be x. then for per unit area, it would be A by X, correct? It is just basic unitary method, right? Like for example, if I have five children, I am giving, let's say 10 toffees. So then per student, how many toffees they are getting? It would be just 10 by 5, right?
Two.
Two toffees for each student. So similarly, if I'm saying that A to B is my whole area or whole length, then per unit point, how much? What is my probability value? But don't consider it to be the exact probability value. It is the density, you can say. Like if as I was talking about that, let's say in the let's say there were, I was saying it in one session, I think, that in an area, let's say there were you are finding out the weights. Okay, let's say in a whole area there were 50 stones and each stone weight was 5 kg. So what would be the, for a small unit area, what would be the density of weight in that area? And let's say your the whole area is supposed to be 20 kilometers square, and I'm saying that you have 50 stones in that area. So what would be the density of weight in for one stone? It would be basically how much? Or per unit area, how many stones you can find out? If in 20 kilometers square you have
50 by 20.
50 by 20, sir.
Correct. So that would give you that in per kilometer square, how many stones we have, right?
Yes.
It is kind of intuitively that in a small area, small length or small area, what is my probability density? Because ultimately my density, the probability is spread out in the whole range of the random variable, right? So in general, you can get these are straightforward. I think we are already too late for this part. I'll start with this part. Do anyone anywhere any doubt? Then I'll just go through that. The variance expected values, you can find it out, right?
Yes, sir.
And for the Poisson distribution also, in general, it would start from 0 and.
Sir, do we have to memorize all these things?
Correct. You have to keep in mind all these things, or else the other part is that you have to derive it in exam hall. And I don't think in an hour time you can derive it, right?
Yes, sir.
Not an hour. I think 1.5 hours, right?
Yes, sir.
So it's better, and it's not memorizing exactly. Once you start doing the questions, like for example, when you are doing binomial, it is just NCR and P of R. And if you know which part is what, you can easily get, like you don't even need to remember it. If you just try to break down each formula, you can get it. Like for the other part, it was hypergeometric.
Simple, sir. I am talking about variance and expectation of continuous random variables.
That part maybe you have to remember. That is just 2-3 formulas, right?
Yes, sir. Cumulative functions.
Correct. Yeah, you have to remember those parts. Else it would be time consuming in the exam. Okay, now we'll go to the geometric part. Okay, so basically, what is a geometric distribution? Anybody, any idea? Anybody, after you got the mail, have you researched on this?
Sir, till you get
It's
the
like binomial
success,
distribution.
you have to like until you get the success.
Okay, Saloni is done. Yeah, Saloni, you are right. Anyone else would like to add on anything?
Quick question on this. Do we have to just look at the first lecture on geometric distribution, or do we have to also that only covers the geometric distribution? It doesn't cover the value of geometric distribution variable and variance. So do we need?
So from the first, are you talking about stats 2?
No, I'm talking about stats 1. So we need to cover geometric distribution, right, for the final exam.
But do you have the access to the lectures of geometric distribution?
Yesterday, I think the other sir shared the link on YouTube. So I looked at the first lectures.
Okay. If you have the access to the lectures, yeah, it would be enough. Only that part only. Okay.
Okay.
So basically, I haven't seen the lecture, so I have no idea. So basically, you will also receive a PDF document in your. It will be added. Maybe it was supposed to be added today, but because the instructor said that because you all may not be having any idea about the distribution, what it is exactly, so the PDF won't be of any use, right? So once we give you a rough idea, then we'll upload the PDF tomorrow. Okay, so you can go through it. So other than means whatever would be the content of the PDF, that is the content would be very brief summary of what is geometric distribution, right? What would be the PDF of it? Sorry, what would be the PMF of it? What would be the CDF of it? In general, there will be basically 3-4 formulas and 1 or 2 questions out of it. Other than nothing would be out of those implementation, or you won't be asked to use any other formulas out of whatever would be mentioned in that content or whatever in that PDF. Okay.
Okay, sir, could you please give a slight idea about what it is?
So what anybody who all have gone through the lectures, like I think Karthik, you were saying about the first lecture, and Sanjali also. Can you tell me how is it different from binomial?
Sir, may I?
Okay, one after. Just raise your hand. I will ask one individually, one after. Those who want to explain your thoughts, just raise your hand.
So it actually deals with the n number of, like, infinite number of trials where and you have to calculate, you have to continue the trial till you get a success.
Okay. Anything else anyone wants to add on? Sneha?
Yes, this only, sir.
Okay. So basically the same thing. I'll just add on one point, that in binomial, for every trial we were individually trying to find out success, failure, right? But in case of geometric distribution, we don't do that. In geometric, we are only concerned about our first success. After that, we are not bothered about anything. Only for till the first success, we are taking our observations. Okay. So I think in the last term also, I was when I was explaining this to stats 2 people, the same example I'll try to give you over here also. That let's say you are giving your exam, okay, end term exam, and I am asking you that you have 3 exams, right? Quiz 1, quiz 2, and end term. These 3 exams you have. Now I am saying you that the probability of your success in any exam is, let's say, 1/3, and the probability of failure is 2/3. Now I am asking you that what is the probability of you passing in 2 exams? So what is the distribution we are asking about? It's binomial, right? Is this clear to all why we are talking about binomial? You have 3 exams, quiz 1, you have quiz 2, and end term or the final exam. And I'm asking you, what is the probability of a student passing in exactly 2 exams?
So it would be 3C2 into 1/3 to the power 2 and into 2/3 to the power 1.
Correct. Now, if I have to frame the same question for a geometric distribution, what would I say? That what is the probability that he will pass in the second exam? Or not, he will not pass in the second exam is the wrong way to say it. What is the probability?
Second exam.
Sorry?
Pass before the second exam.
What is the probability that he won't pass before the second exam? Okay. He won't pass before the second exam. So what does this mean? That in the first exam, what would be his result?
He will fail if we want. No, he will.
So in quiz 1 he has failed, and in quiz 2 he
will pass.
Success.
Will pass. So what happens in general? How it is different from the binomial? Let's say there were n trials. Let's say 5 trials. Okay. So let's say 5.
Sir, both questions became different. No?
Questions will be different. Questions will obviously be different. I'm just saying
you told that how to frame this question. So earlier the question was that how he will pass in 2 exams, exactly 2 exams.
Exactly 2 exams.
Both questions are different. Both questions are different.
Yeah, the questions are different. I'm talking about the scenario. The scenario would be the base question. This, if you can divide it, like there will be one random experiment and you are asking out some for observations or some event to occur, right? So your random experiment will still be same. That is, there will be 3 exams and you will be given some probability. But what event you are concerned about, that is changing. Over here, I was talking about exactly means in 2 exams to pass. And in the second case, I was asking about that he won't pass before the second exam, right? So it's a 2 different events we are talking about. But ultimately, the experiment is same, right? That is the base question which you will be reading in the exam. And from there, you have to pick out the distribution, correct? Okay, so basically what I was talking about, that the 5 trials. And in these 5 trials, if I'm talking about binomial case, then this, let's say this can be success, this can be failure, again this can be success, this can be failure, again this can be failure. But once I convert this into a geometric distribution, how can this change, anyone? It would become that this all would be failure, and you are ultimately getting success in the last attempt. Wherever we are getting the success, rest will not be considering. Okay, we are talking only till our success attempt. Okay.
So my X will be the 5th one, sir. X will be
Correct.
5.
Correct. Your X will be 5. Okay. And before that, all your attempts would be failure cases. So now
Q
how
raised to power 4 into P.
Okay. Sir, will the question be like, in 10 trials, what is the probability of getting first thread in 7th trial or something like that?
Let me finish this part, then I will go discuss the question part. Okay, I'll discuss with you some questions. So how is it different from the binomial PMF? I'm trying to just correlate with binomial so that you don't get confused. This was NCR, probability of R to the power 1 minus P to the power R, right? In this part was what? That out of those n trials, how many were success? P was the success to the power R, means in the R trials where we got success, and this part was the failure case. Now in this case, if you see what I'm saying, that the earlier 4 cases are failures, right? So basically I will take this part. So it would be 1 minus P, and how many, if I have n number of trials, so what would be to the power?
Minus 1.
Correct, exactly. It would be n minus 1. And in the nth attempt, it would be what? Just P. Are you getting how it is correlated to this part, binomial case, how the formulas are correlated?
Yes, sir.
Yes, sir. Yes.
And will not be having NCR part because arbitrarily I'm not choosing which trial I will be having success. It is already fixed for us that beforehand all my cases would be failure and the last attempt would be success. So this part vanishes, NCR part. It will be just P at P to the power n and 1 minus P to the power R part. So which would become 1 minus P to the power n minus 1 and P.
Or we can take also, sir, NC1 will be 1. Means that is
no.
That,
It doesn't make any
NC1
sense.
is not 1, NC1 is N.
NCN.
But that doesn't make sense to us, right? Over here, NCR was out of n trials, how many success I'm getting? NC means R was my number of successes, right? But over here it is fixed. What will you choose? There is nothing to choose. You are fixing means failure for the other attempts, and you are fixing success for the last attempt itself.
So you cannot use the combination formula there because in combination you are saying the success can be at any of the places out of n. But here you are saying the success always has to be at the last place.
Exactly. In the last trial, always success has to be there, right? So that is the difference from the binomial case. Or you can frame it this way also. If I have to, that in the first attempt I failed, in the second attempt again I failed, in the third attempt again I failed, in the fourth attempt again I failed, and in the fifth attempt I pass. This is what ultimately, if we break it down, right? The PMF for x equals to 5. Is it clear now? So there is no NC part in this. Okay. So this is the geometric distribution. What do you say? The PMF. Okay. So now if I have to explain a question to you. Just a second. Give me a second. I'll write down the question so that would be make it more clearer to you. No. Okay, so we are saying that people are playing. You all got bored because of exam and you are playing Ludo. And let's say anybody just give me one arbitrary name. Let's say Abhishek. Abhishek needs to, pardon me for my bad handwriting, repeatedly throw unbiased die, okay? Unbiased dice, till he gets a 6. Till this the question is clear. You are playing a Ludo game, and Abhishek needs to repeatedly throw the die, and the die is unbiased, okay? Until he gets a 6. So what is the probability that he needs fewer than 4 throws? Is the question clear to all? Am I audible, guys?
Yes, sir.
Yes, sir.
Yes,
He
sir.
needs, he needs,
So there is a game of Ludo and Abhishek is the player. Now he has to continue to play, means throw dice till he gets 6. So what is my success over here? Anybody?
By 6.
The number of times he throws to
1
6.
by 6.
Getting 6.
When he reaches the first 6.
1 by 6.
Hold on. Let's divide it. What is the how will you trace out what is my success?
1 by 6.
Getting a 6. Getting a 6.
Getting 6 in third time.
Getting the first 6.
No, don't mix it with attempt. Attempt is not my success thing.
Yeah.
Getting a 6 is my success.
It is 1 by 6.
1 by 6.
Getting 6.
Getting a 6 is my success. Now, what is the probability of getting that success? We'll see that it's an unbiased dice. So in a dice, I can get 1, 2, 3, anything out of from 6. So my success is 1 by 6, and my probability of failure would become
5 by
5 by 6.
5 by
Okay.
2.
This part is clear till this. Now come to the second part. What would my x value be? That is a random variable, right? That is if
Less
I'm
than
finding
4.
It can be 1, 2, 3.
1, 2, 3.
It can be 1 or 2 or 3.
till he gets, what is the probability needs fewer than 4 throw? Correct. X equals to 1, 2, 3. Okay. Now, if you have to find out, you can find out easily probability of x equals to 1. What was the formula? When I'm saying x equals to 1, okay. First thing is, can you tell me that can I take x equals to 0?
No,
We can't take it.
there won't be any throw there.
Correct.
0 trial is not, doesn't exist.
Exactly. So practically my trial has to be there, right? So either it's a failure or something, x can't be 0 over here, right? Because ultimately, even if it's in the first case, because ultimately in geometry case, I am stopping it when I'm succeeding, right? So if I have to start at x equals to 1, means in the first attempt only I'm getting 6 or the success, correct? But there is no way I can interpret x equals to 0. So always my x will start from x equals to 1. So never confuse it to be that I'll put x equals to 0 and I will try to find out. Okay. Is this clear, guys?
Yes.
Yes.
Okay. So for x equals to 1, what does that mean? Means physically that in my first trial I'm getting success. So what it would be? The value would be probability of x equals to 2. It would be what?
5 by 6 into 1 by 6.
Correct. Probability of x equals to 3, what it would be? It would be 5 by 6
to the power 2
into 5 by
1 by 6, right? So this would give, and I have to sum it up and I will get it. Now this is one way of doing it. There is other way of doing it, that is through CDF. Like for every distribution you have the PMF and the CDF, right? So for this also I'll be having the CDF. And what would be the formula for that? You have to remember, I think most approximately these two formulas will cover your whole questions in the for the end term. Okay. If any more formula is needed, I'll put that in the sheet which will be shared with you tomorrow. Okay. So it would become 1 minus okay, the CDF
P. Yeah. 1 minus 1 minus P to the power of n.
Okay. So when I'm talking about this, so for this case, if I have to try this, so this is the formula for the CDF. Okay. So in this case, if I have to take it, means interpret in the form of CDF, how would you find it out? Anybody? what should be I write it for the probability means notation would be what? Probability of x?
X less than
Less
4.
than equal.
Less than equal to 4, yeah. No, no, less than equal to 3.
Less than or equal to 3.
Exactly. So it would be just I will put my formula 1 minus 1 minus p to the power n, and n would be over here 3. Okay. So it is 1 minus p. This p is what? My success. Okay. So it is 1 minus 6 to the power 3. And if you check, you sum it up through this also, what answer you will be getting, through this also you will be getting the same answer. Okay. Is this clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
So basically, these would be the kind of questions you will be getting, very direct question from geometric distribution. Still in that PDF which will be shared tomorrow, I'll try to incorporate 2-3 more questions so that you get a brief idea. But in general, this is what the geometric distribution is all about. It's just a subset of binomial distribution where it's a different case of binomial. Okay, where we are just not bothering about.
Variance and expectation.
Sorry.
Variance and expectation.
No, most probably whatever the question would be coming in the exam, there you won't be asked from variance and expectation. So let's not confuse everybody with variance and expectation. Just it would be implementation of means you can directly find out just by PDF and CDF. Okay.
Excuse me, sir.
Okay.
Yeah.
Sir, from where will be able to access the PDF of this geometric distribution?
It has not been shared till now. It will be uploaded tomorrow. Maybe in the first of maybe by second half of tomorrow you can find it in your dashboard. Okay, it would be under that additional content you have something, right?
Okay, sir.
In that you will get the PDF. It will be 1-page PDF. Basically the same things what you have discussed today will be mentioned, and maybe 2-3 more extra problems and detailed solution of that. Okay.
Okay, sir.
Sir, is exponential distribution is also in the exam syllabus?
Those are from your regular syllabus only, right? Till week 12. Those will be there. This is just an additional content. That's it. This geometric distribution.
Because you have not revised this.
The geometric thing. Okay, I'll do it. Just because I didn't want to miss on the geometric part. That's why I just covered it first. Okay. So exponential distribution, the first important thing to keep in mind is that what are the possible values your random variable can take for the exponential case?
0 to infinity.
Exactly. Your x can never be less than 0. Okay, this is a point to be keep in mind. And then it is just the formula which you have to keep keep in mind. Any general see, there are 2 parts to a question over here. Like if you have been given exponential distribution, it would be arbitrarily mentioned in your question. Okay, there is no trick to it that through this you can find out that this is an exponential distribution. Either you would be given some lambda value, or it would be given that it's a continuous distribution and it is not uniform, and there will be some average value that would be given to you, and it would be depleting. Like I think everybody, if you have if you are from science background, you would have done this that decaying case, right? That radioactive particles getting decayed over the period of
Carbon dating.
Carbon dating. Those all follow exponential distribution only, because it is same like Poisson only, that it is over a period of time it's happening, but it's a continuous case. Okay, over a Poisson case, what it was the difference between Poisson and exponential? Over there it was discrete values you are taking. Over here it is exponential. It's a continuous case that's happening, that you can take arbitrarily any value in your range. Okay, and then you have to just find out that if it's given more than 10 minutes, it would be something x greater than 10, or sometimes you have to maybe implement the CDF and try to find out, and rest it's just the implementation of the formula. That was something e to the power minus lambda.
What is lambda here?
Sorry, it is again the same. It is it's kind of the parameter for the whole distribution given to you. Okay, so
is it the mean, like in Poisson distribution?
You can consider it to be the mean, but you have to again see that because it's a continuous case, it's not in normal mean. It's about that you are integrating throughout the whole area. Okay, and then you are trying to take whatever the physical significance for that particular lambda value comes out to be. Okay, over there, because it was discrete, we could exactly tell that okay, let's say in one interval, this was my number or this is my number, count in that way. But over here, it's a continuous case. So X can be any value from 0.1, 0.2, 0.3, 0.4, anything, right? Arbitrarily any values. Like for example, over here, if you say, suppose that the length of a phone call in minutes is an exponential random variable with parameter lambda 0.5. And someone arrives immediately ahead of you at a public tele, find the probability that you have to wait for more than 10 minutes. So can you tell me what would be the frequency over here? Anyone?
10 minutes.
Sorry? What is the frequency of time? It is in minutes, right?
10. Yeah.
10.
No. I'm not talking about 10 minutes. I'm talking about like in for the what is the distribution name? For the Poisson distribution, we were talking about an interval of time, right? That we were observing, right? In this case, what is the interval of time we are talking about? It is in minutes, right? That in every minute, what is the length of the phone call? Is it okay? Now we are saying that in the length of the phone call, it is 0.1. That is the amount of time we are talking is 0.1. In every minute, we are getting a phone.
One.
What is this, sir? Lambda?
Lambda value is that in every minute, I am getting the length of a phone call to be 0.1 on an average. Okay. If you see this part, exponential distribution amount of time until some specific. Okay, this part, the length of a phone call, right? This part, if you see, this is my average. If when I'm talking about lambda over here, it is the average length of my phone call. Okay.
Okay. When in question, sir, it is always written parameter lambda is something.
Exactly. It will be mentioned in the question because for different distributions, it would be in different way, right? Or if it's not given you exactly lambda, they would give you that in every minute, this is the length of the phone call is supposed to found out this. So you have to assume it that, okay, if they're asking it in every minute or in a minute, then this is the average they have noted it down. So that would be my lambda value, or that would be the parameter for this distribution. Okay.
Sir, if it is average, then expectation should be same as lambda. Then, but expectation is
Expectation is 1 by lambda.
Because over here, it is what? It's a continuous case, right? It is not exactly what you are finding out for the discrete case, how you are finding out for a continuous distributions, right? In general, what happens in a continuous case? What is my whole what is the probability value? If you integrate it to be, you will get to what would be the it come out to be? It is 1, right?
Yes, sir.
Now, when you are talking about for a particular unit of time, you have to just take it whatever has happened in that means, let's say for what do you say? It is, let's say, in 1 minute of time, right? Now, if I have to find out that how many what was it? How many length of what is the length of a phone call or average length of a phone call in that 1 minute? So that comes out to be my 0.1. But does that mean that in that 1 minute you have got exactly always you will get in every 1 minute of time it will be 0.1 only? You won't get it, right?
Also.
In the whole distribution, in this whole part, it's on an average, this is the 0.1 value. But when you are talking about the expected value, we are not finding out for the what do you say, in discrete case, it was that the average value. But in what do you say, in the continuous case, I have to find out the whole area and then I have to take it for this average part, right? In like, for example, if I have to take the expected value, it is integration of this f of x, right? So it is for each strip you are finding out the fx and then you are multiplying it with the x value and then I'm trying to find out a center value out of it. Isn't it?
Yes, sir.
So the interpretation changes a bit. Okay. I think that's all to be covered in this part. Anything else or else we'll wrap up? It's already too late.
The PDF and geometric distribution, can you show that example?
For which distribution you're talking about?
Geometric distribution.
the PDF for the geometric distribution would be the PDF would be 1 minus p to the power n minus 1 multiplied by n minus 1 multiplied by p. Okay.
Yes,
And
sir.
yeah, you're saying
PDF.
something.
Yeah,
So
so I was
PDF
asking that example where 4 throws, fewer than 4 throws wala example.
so that
So
example, yes,
Px is equals to 1 by 6. Px is equals to 2 is 5 by 6 into 1 by 6.
no, this is the problem I'm talking about. Not go step by step. First, find out what is your success criteria. How can you? When will you say that you have succeeded?
If I get a 6.
Correct. So probability of success, how much it would be? What
1
is the
by 6.
probability of getting a 6? 1 by 6. Probability of failure, that would be other
5
than
by
6,
6.
get anything, right? So 1, 2, 3, 4, 5, anything. So it would become 5 by 6. Is this okay?
Yes, sir.
Now I'm saying that what is the probability of he getting a 6 until what was the question? Exact word.
In less than 4 throws.
What is the probability that
4.
he will need fewer than 4 throws, okay, to get a 6. So when I'm talking about fewer than 4 throws, so what does that mean? That means that in the third throw he will get a 6. That's when he will stop, right?
Right, sir.
So in the first throw he will not get a 6, means he will not get a 6. In the second throw also he will not get a 6. In the third throw he will get a 6. Is this clear?
Yes, sir.
So I'll be finding out PDF is probability of x equals to 3. Okay. So this x value is when he is getting the success. Until then he has not got the success. Okay.
Okay, sir.
So this becomes 1 minus p to the power 2 to the power p. So it becomes what? 5 by 6 to the power 2 multiplied by 1 by 6. Okay. This 5 by 6 comes from this. In the first part I did not get a 6. In the second part also I did not get a 6. In the last part I got a 6. Okay.
Okay, sir. I got it now. Thank you.
Or you can do it in the CDF format also. It would be just 1 minus, you can do it probability of x less than equals to 3. Okay. Okay. I did a blunder over here. It's not exactly px equals to 3. Okay. We have to individually find out for all the cases.
Less than 4. So we should add all x is equal to 1, x equal to 2, and x equal to 3, right, sir?
Correct. It is probability of x equals to 1, x equals to 2, and x equals to 3. Either I'll be getting in the, because the question is that fewer than 4 throws. So it can be in the first throw also, it can be in the second throw also, or it can be in the third throw also, right? It's not given that exactly in the third throw. So we have to find out for x all the 3 cases. Or you can do it x equals to less than 3, and in that case it would be 1 minus p to the power 3. Okay. Is this clear to all?
1 minus p to the power 3 into p.
So the PDF will change.
PDF will change for what?
We are saying now that less than 4 throws. So we were calculating for exactly third.
No.
In third throw we will get the success.
That is my mistake. I'm sorry for that. When you are saying that fewer than 4 throws, I can get a 6. What are the possible cases? I can get in my first throw 6. Correct. I can get in the second throw 6 also. I can get in the third throw 6 also. Till this it's clear?
Yes, sir.
Now if I'm getting in the first throw 6, then directly I'm getting 6. If I'm getting in the second throw 6, then it would be in the first throw I did not get a 6. In the second throw I got a 6. If I'm getting in the third throw 6, then in the first throw I did not get 6. Second throw also I did not get 6. In the third throw I got 6. Is this clear?
Right, sir. Yeah.
Now for each individually I'll find out the PDF. For this first case, what would be my PDF? It would be just 1 by 6. That would be probability of x equals to 1. Okay.
Yes, sir.
In the second case, what would be my PDF? I have to do 5 by 6 multiplied by 1 by 6, and that would give me my probability of x equals to 2. Is this okay?
Yes.
In the third case, it would be 5 by 6 whole square multiplied by 1 by 6, and that would be the probability of x equals to 3. Is this okay?
Yes, sir.
Now, when I'm saying interpreting this part, that is fewer than 4th row, it is ultimately x less than equals to 3. So it would become probability of x equals to 1 plus probability of x equals to 2 plus probability of x equals to 3. Okay? Is this clear?
Okay. Yes, sir.
Or I can find out by the formula of CDF also. That is probability of x less than 3 becomes 1 minus, this is the formula of CDF for geometric distribution. Okay, it is n. So this is 1 minus this is 1 by 6 multiplied by to the power 3. In this way also you can get the answer. In this way also you can get the answer.
Sir, you told me that x, we are not taking x equal to 0 this case, x less than or equal to 3 case.
Correct.
So why here?
Yes. Yeah, carry on.
Sir, yes, sir. When x equal to 0, what you say? If you take x equal to 0?
See, the geometric distributions always we are interpreting in the way that when I am getting my first success. So if I have to get my first success, then there has to be one trial at least, right? Or one attempt.
Yeah, sir.
So if I'm saying x equals to 0, then there is no attempt at least at all, right? So it has to always start from x equals to 1. That is, when I'm saying x equals to 1, that is that in my first attempt only I'm getting the success. That was like 1 by 6, right? But if I don't have any attempt, then how will I have success or failure? Whatever it is. Is this clear to all?
Yes, sir.
Okay. Sorry.
Sir, if the question is that he is going to get success.
I'm not. Can you just be a bit louder? Maybe I don't know. Your voice is breaking.
If the question is such that he gets the success in more than.
No, there won't be more than one success. Okay, then it would become a case of binomial. In geometric case,
you will get the success only after third. That will be 1 minus less than 3.
Anyone else? Are you able to get the question? I'm not. Sorry, I'm not getting your question. Anyone can explain?
My question is, sir. My question is, what is the probability that he will be able to get the success only after third attempt?
Okay.
After, it's not clear.
Only after third attempt, he's saying.
Okay.
Okay. Yes. So basically, only after third attempt when you are saying, so it is like you are getting in the 4th attempt, right? Or you can get it in the 5th attempt, or you are getting in the 6th attempt.
But will it be, sir, probability after up to third attempt 1 minus?
Exactly. Yeah, exactly.
Okay,
you will do it that.
That was the point.
Okay.
Thank
you. I'll try to include this complement part also. One of the questions from complement part also in the PDF. Okay. So that it becomes.
Sir, I have a question. Can you tell if a CDF or a PDF is given, then how to get P for maybe binomial distribution?
See, the basic thing is what does the CDF says? For example, for geometric cases, it becomes easier. Or if I have to, let's say, for find it out for the PDF means continuous case also. Let's take that up one. So let's say your x equals to 3 and your x equals to 4. Always, whenever you want to find out the CDF, I think what notation do you use? You use this F, capital F only, right?
Yes, sir.
Okay. So you find out x equals to 4 minus x equals to 3. This would give you the probability of the probability of x equals to, anyone can you tell me what would this give?
This is less than 4 and greater than 4.
Basically that if you are talking, I'm using capital F, or you can say that probability of x less than 4 minus probability of x less than 3. So what would this value give me? Anyone?
It will give
And
the
that is probability,
in the range 3,4.
1 by 1, 1 by 1.
probability between 3 and 4.
Between 3 and 4. Okay. Anyone else? Anything?
Excluding 4.
Okay. Let's. I'll just try to give you a better interpretation. Let's say over here I'm starting with 0, and over here it is 1. Let's say 2, 3, and 4. Okay. So initially my probability was 0, and let's say till this my probability better it's to get it from step function. That's why I'm using it. So let's say over here it's 0.2, and for second case, okay, I just messed it up. I'll try to draw both the cases, then it will be easier. So let's say I'm doing a PDF first. Let's say for probability of getting 1 is, let's say 0.2, and probability of getting 2 is, let's say 0.4, and probability of getting 3 is, I'll decrease it. Let's say it. Let's say it is again somewhere this part. Okay, I'm writing it over here. 0.3. Okay. Now, is this clear? So what this PDF, this PMF says that probability of x equals to 1 is 0.2. Probability of x, or PMF of x equals to 2 is 0.4, and the probability of x equals to 3 is 0.3, right? So now tell me.
It won't add up to 1, right?
Okay. Okay, just make it 0.5. Okay, now it's okay.
Yeah.
So let's say this is 0.5. So now tell me, can you draw the CDF for it? Tell me the CDF for it. For x equals to 1, what it would be?
0.2.
Correct. So it would start somewhere at 0.2, and then it will keep. So it is over here.
It will jump 0.5. It will become 0.7 at 2.
Hold on.
0.2, sir.
So till this it would be 0, and at 1 it would go to 0.2, right?
Yes, sir.
Now again till it will go till 2. Let's say, shit, where did it go? Okay, over here. So basically, okay, where I was. So this is, let's say 0.2. So once you have this 0.1, so now till 0.2, till 2 it would be the same value, right? Because it's a discrete condition. So
That's
till
right,
that it would be 0.2 only. And at 2, what would be my value?
It will jump 0.5. It will jump
0.6, sir.
0.7.
0.7. It will jump to 0.7. 0.2 plus 0.5.
0.5 or 0.4?
0.5 it is.
Corrected
So
it to
0.7.
0.5, no, because it was not coming to 1.
So it will go to
0.7.
Yeah, it will go to 0.7, right? So this part it will be, and then again at 3, it would jump again to 1. So now if you see, interpret this part, what would be this height actually?
That is the individual probabilities. No?
This height is actually probability of x equals to 2. This
That's
height
right.
is actually probability of x equals to 3, correct?
Yes, sir.
Now this part, can I write it this way also? That probability of x less than 2 minus probability of x less than equals to 1. Can I write it?
It would be
Yes, sir.
CDF of no.
That x less than 2 is CDF only, right?
Okay.
Yes, sir. We can write it.
Yes, sir. Yes, sir.
So now did you get the interpretation? That so this would become probability of x equals to 2 basically, right?
Yes, sir.
Similarly, if I have to find this part, again just check it. So if I write probability of x, this part is less than equals to 3, correct? So probability of x less than equals to 3 minus probability of this part, this side. This would be what? Probability of x less than equals to 2.
That's probability of 3.
That would give me probability of x equals to 3, correct? Or in a very rudimental way, if I have to say that if you had 5 rupees with you and now somebody comes and gives you 10 rupees. So in general, what is the jump you have or the change in that is 5 rupees only, right? And that would be, so if somebody, somebody asks you that what is the exact value that person gave you, that is, you have to subtract it out, right? That initially how much money you had and the new money that you have. If you subtract that out, that would be the impact of that person who has given you the money, correct?
Yes, sir.
So any place, if I have to find out x equals to 3, what is the CDF at that particular value and what is the CDF at a previous value, that would give me the impact of that at that particular point. Okay.
Yes, sir.
Is this clear to all?
Yes.
Okay. I think that's enough for today. Else we'll continue till tomorrow morning only.
Thank you, sir. And next session will be discussion of problems.
We'll be discussing PYQs. Okay. So from we'll be picking up some questions from the last maybe 2-3 end terms and we'll try to solve.
Okay, sir. Thank you so much, sir.
Okay. Good night, everyone.
Sir,
Good night.
sir, is there any mock?
Mock session, it would be
Sir.
on Saturday. Yeah, there will be a mock session on Saturday. I think isn't it updated in the calendar yet?
No, the mock session is updated.
Updated.
So mock hasn't released yet, sir.
Sorry?
Mock paper released, I didn't release.
Okay, it has. I'm not sure about it. I'll talk to the team once. Even if it's not released, they will release it very soon. Okay?
So there are two more sessions to come then.
Most probably there will be 2 more sessions. One would be on Friday and the other one would be on Saturday. Okay.
Okay, sir.
Okay. Bye, everyone.
Thank you, sir.
Good night,
Thank you, sir.
Good night, sir.
Good night.